welcome to Math Monday, number 2. I am super, super excited. Fingers crossed that my light here, it's precariously balanced right now. I'm gonna actually see if I can turn it down a little bit. That it doesn't go anywhere, because right as I started stream last time, the light fell over. So let's hope that doesn't happen again. All right. Yes, Math Monday time. All right. So let's see who I've got here in chat. Def Hacker, woohoo! It's so good to see you here. Space Bay, Crow, and Triumphant Base, and Carlos of Gingerfell, and Nakas, and Manny Manatee coming in with the Learn with Leon emote. It's good to see all of you. Hopefully you're having a wonderful Monday. I actually had today off, so it was kind of nice to be a little bit lazy. I'm just gonna plug in my tablet here, get us all squared away. All right, so tonight is day 2 of Math Monday. And we're gonna be talking about, we're gonna do a little bit of a review, so folks who missed last week, don't worry. But once we do a little bit of a review, answer any questions left over from last time, we're going to get started with diving deeper into the kinds of functions that we talked about last time. We're going to look at some more graphing, inequalities, and something called linear equations. So lots of cool stuff happening tonight. So hopefully you all are in a math mood. You have your math socks on, your math pants on. Alas, my math socks are still in the wash. So I wore them last week, but I need more math socks, I think is the answer here. And thank you for answering the questions about the captions, Loafbone. So they should be customizable. Those of you watching on YouTube should have them embedded via YouTube. Unlike YouTube, Twitch lacks default captions because it's trash. But hopefully the third-party extension will work for you. I've had good luck with this one. I've tried out actually a couple of different closed captions extensions, and none of them have been consistent enough to really rely on. Hopefully this one will be useful. Okay, and let's see here. Crystal Coder, you're not wearing any socks. Don't worry, that is not a problem. You can wear your math socks, in your heart. You can wear them in spirit. And BST Twit, you say you have a math degree, but I can remember any of this stuff. Hilarious. Well, we are starting at the beginning. And, just as an introduction to folks who haven't done any Math Monday streams, there's only been one. Really what this is about is I want to go back to the fundamentals. Because a lot of times when I have been teaching math, there are gaps or misconceptions or misunderstandings that start all the way back with algebra or even before. So this I think it's the best place to start. And no worries, Guppy, you say you can't be here for the stream, so you watch on YouTube. Also feel free to join the Discord. So the one thing you do miss out on if you're on YouTube is kind of the Q&A. So being able to ask your questions in chat, get that answer, get that feedback from me. So if you can't be here for stream and you're watching on YouTube, please feel free to join the Discord because we do have a math channel. So if you have any questions about any of the videos, tag me. I will answer math questions all day long. But let's see here. Okay, and gaze into the iris. You say it's too hot for socks tonight. That's okay. Like I said, you can wear your math socks in spirit. Def Hacker, you say you're wearing a math shirt right now. I'm jealous. I need more math shirts. I have some I have a Science March t-shirt. I have a couple different accessibility conferences and like accessibility and STEM shirts. And then I've got some ComSciCon shirts. But all right, let's see here. And Mary G asked before algebra. So there might be times where we're gonna, dip back a little bit into things that you learned before algebra. Because sometimes, there's a lot of misconceptions and misunderstandings about fractions and decimals and, number sense that sometimes can affect the things you learn in later classes in math. So whatever we need to learn, we'll learn. That's pretty much my approach for this. And yes, also Loafbone mentions YouTube comments are also a great place to ask. I try to get to them as fast as I can. And I think I've pretty much answered every single one that I've gotten. So, and the sculptor, you ask differential calculus and Laplacian transforms and initial value problems. Well, eventually, yes. So, like I said, there is actually quite a few Twitch streamers. There are more people streaming advanced math on Twitch than there are people starting at the beginning. So if you want the more complicated math topics, you're going to have to wait a little bit. But really, I wanted this to be for the vast majority of people. And the largest amount of people start to struggle in math when they move from arithmetic to algebra. This is where the abstraction starts. This is where we introduce variables. Suddenly we're using letters. And this is where people start to dislike math a lot of times. So we have a raid. What happened to my notifications? Did they pop up? I'm looking at you, Streamlabs. Thank you so much, The Diabolical, for a raid. Welcome, raiders. Welcome to our math party. Thank you for the shout out for The Diabolical. If you've ever wanted to learn JavaScript, check out his stream. Excellent, code reviews, very excellent pacing, answers all questions. So if you want to know all the things about JavaScript, check out his channel. But let's see. Making sure I don't miss any questions. And the sculpture, you say, it's basic preschool stuff that people forget the most, to be honest, even me. Absolutely. And it's also, one of the things that I've noticed is that, I talk about this a lot on my stream, but math is often taught really terribly. There's a lot of just memorize. So you should know something about Math Mondays. I have a no memorization policy. We're not going to be memorizing anything here. If you learn a formula or something and you don't I don't explain it either well enough, you should ask questions. But if it's one of those ones that's just long and you're like, I've got an intuitive sense for this, but everyone drops a negative or something, you look it up, all right? There's literally no reason to memorize. I'm sorry. Hot take. Memorization is a waste of brain space. And NB, you say you love algebra. Well, you're in the right place. I'm so glad. And hi, Cole Modello. Welcome. And Con Tipper. Also, let me know if I mispronounce any of your names, please. Thank you so much for following. And you say, when I was taking pre-calculus, it felt so hard, to be honest, but now calculus feels easy. That's great. And I think the more that you're able to apply math, the easier it gets. So that's not the more you're able to do worksheets. It's the more that you're able to see math in context. So the more that you're able to think of real world problems and see how, a lot of us use math every day, but also how there are lots and lots of real world applications for even the most complex of math. Complex things of math, topics, whatever. And let's see, Green Jenny, you say, algebra and trig is where the teachers often start to get out of their depth as well. Absolutely. And a lot of times it's not their fault. Teachers are undervalued, underpaid, and I think if we were to invest more in our teachers, we would have higher quality of teaching. But a lot of times when you start to teach algebra, you need to be able to pull from much, much, much higher math classes or math topics. A lot of times you get asked questions that you can't answer unless you know calculus or unless you've really studied this stuff. And so a lot of teachers get really threatened if they don't know the answer, and they tell you, just listen, just do your work, just be able to regurgitate this. Well, guess what? This isn't a class. I'm not your professor. This is the time to do it right, because I don't give you homework. You don't have to raise your hand. If any of you feel stressed asking questions, you feel like you don't want to look stupid, even though I promise you, you won't. Feel free to DM your questions to Loafbone, and he'll make sure they get posted in chat anonymously. So this is low stress, no memorization, no expectations. We're just gonna, sashay our way through math. And Cole Modello, thank you so much for following. And DFDX2, thank you so much for a 2-month subscription. And also, Loafbone, I noticed that you resubscribed for 24 months. I don't know have you been subscribed for two years? Goodness. I could have sworn, but you've been here for 3. Just kidding. Thank you so much for 24 months. All right. And yes, and the diabolical, let's see. You say thank you so much for the shout out. Of course, of course. I love your stream. I'm so glad to have you and more of your community here. I know we have a lot of people in common because I've got a lot of people in common with Learn with Leon, which is like, I don't know, the coolest feeling in the Twitch analytics when I get to see so much of my community comes from Learn with Leon because it is an amazing community. I'll get a shout out. So if you're interested in full stack web development, I believe. And he's got the best music. I'm so jealous. And a cool layout. Such a good... And the weird statue thing. So, you should definitely check out Learn with Leon. Bob, I'm sorry. Yes, Bob. I don't understand Bob, but I appreciate Bob. But if you're interested in learning more about full stack web development, he is doing a free boot camp. Seriously, and the amount of resources that he offers to the community is absurd. So please, if you're interested in honestly anything involving programming, because his Discord has channels for everything. Go check it out. Wonderful, wonderful, wonderful streamer. All right, let's see. I'm a little behind on chat, so bear with me. Sculptor, you say they messed us up even before we got into high school. Truth, my friend. I remember the first time I started getting a lot of bad math anxiety and started to dislike math was actually like 4th grade when I kept getting caught reading under the table. And I just got bored. Like, they would ask me to do 60 problems, like the same kind of problem. And I'm like, I know this. I get you got to practice, but I'm bored. And you also say that physics is what helped you with math because you're a mechanical engineer. That's awesome. Yeah, physics. I did a lot of physics. My graduate school education was in astrophysics. And it was weird because I would actually struggle with the theoretical physics exams, but if I could apply the physics in the context of my research or apply it to a practical hands-on kind of problem, I did great. But it was just kind of the memorizing formulae for the sake of memorizing it that it didn't work for me. Let's see. Crystal Coder, you said, I wish I could become like that guy who got hit in the head in a bar fight and became a math savant. Well, I would say the vast majority of people who get into bar fights probably don't end up coming out with math superpowers, but guess what? You don't need math superpowers because I'll teach you. It's a little, like, confident maybe, but I think we can do it. And yes, let's see. That is your streak. Oh, you lost a month or two when I did stream. Okay, Love Bone. And let's see here. Yes, that is when Learn with Leon made partner. I was there for a part of that stream. So wonderful, wonderful stream. All right, Strawberry Jesus, you've redeemed story time. Okay, hold on. All right. Strawberry Jesus, do you want what kind of story do you want? Do you want me to whip out one of my grandpa's stories? Do you want me to share like a grad school story? Does it need to be applied to math? Tell me what kind of story you want, and I will tell you a story. And Creeping One, you say you have dyscalculia, so doing arithmetic is exhausting and painful, but you can understand the concepts. Integrals, derivatives, linear algebra, etc. just fine. You just can't solve the problems without a calculator. See, and that's another massive thing. Thank you so much, Creeping One, for bringing this up, which is math the way we teach it now is horrifically inaccessible. If you have any kind of learning disability, I have ADHD and some auditory processing problems, and the way that we teach math is extremely inaccessible. So hopefully this will be an awesome chance for you to maybe get a conceptual refresh if you want, or just enjoy the concepts, because guess what? Calculators are totally welcome here. And Strawberry Jesus, you have requested a grandpa story. Okay, have I told you the dynamite story with my grandpa? I know I told you the cannibal story. Have I told you the dynamite story? I love the tell me a story or story time redemption, because I get to tell stories about people who are much cooler than I am. Completely agree, Creeping One. You say math departments are ableist as hell. And Ray March, what's up? Welcome to stream. I'll let Strawberry Jesus. Okay, you want the cannibal story? I haven't told you the cannibal story. Okay, let's talk cannibals, because I've got a couple different grandpa stories that you guys can redeem. I've got the time that Hitler's personal surgeon saved my grandpa's life. I've got the cannibal story. I've got the dynamite story. There's a lot. But I will tell you the story of how my grandfather almost got eaten by cannibals. So, my grandfather was born in Kharkiv in Ukraine. And during World War II, there were a lot of German soldiers that were, I'm not even sure if he was still in Kharkiv or if he was in like another area of Ukraine. But he had a German soldier who would walk him to school every day, and kind of served almost like a mentor for him. And so, German soldier would kind of like pick him up, take him to, they'd walk to school, and kind of like the same route every day. And this one time, though, they're walking, and I forget, I'm not even sure if they had to be at school. They had to be somewhere, and probably school, like there was like a deadline, like they had to be there like soon. And so my grandpa's going along, and this like guy comes out of this random building and approaches him and is like, "Hey kid, you want some candy?" And like, I know all of us, especially those of us who are like, 90s kids, we're sitting here like stranger danger. Like if some weird guy comes at you and says, "Hey kid, you want some candy?" But this was like in the 40s. So it's like, this was before a lot of the stranger danger. And so my grandpa's like, "Hell yeah, there's rationing. Like we don't have a lot of like luxury items. So hell yeah," my like child grandfather was like, "I want some candy." So he starts to go with this guy. And the German soldier turns around and is like, "Igor, what are you doing? We're going to be late. Like, come on." And my grandpa's like, "Seriously?" And probably throws a little bit of a tantrum, but is like, fine. And goes with his German soldier friend. Well, not too long after that, they raided that particular building, and there was a cannibal ring there that was luring children into the building and processing them for food. And so if my grandfather had not had his soldier friend there with him kind of being like, "No, let's go, well, my grandfather would not have survived. So yep. Katya Zeros, there is a story time redemption points redemption that you can make in my channel for me to tell you a story. I've got a lot of wild stories from both my childhood when I was living abroad, and also my grandfather obviously had a pretty wild life. So Strawberry Jesus redeemed grandfather story, and I offered several different grandfather stories, and he picked the cannibalism one. So I try to keep things PG on the educational streams, but I didn't say anything that was too... I tried to not be graphic. Nevertheless, and Creeping One, to get back on topic, you say math departments are a lot more hostile to assistive technology than others. I would say math and physics, yeah. That has been my worst experience with accessibility by far. But yes, lots of people kind of being like, what did I just walk in on? So, you can redeem story time. And there's a lot of different stories. Emma B, you say, my sister was practicing stranger danger with my 3-year-old niece. So if a stranger offers you candy, what do you say, niece? Yes, please, and thank you. Oh, Lord. Oh, yeah. So that's your story time. Oh no, 1 hour cooldown. Well, we do have to get through some content. So let's kind of get started with our math goodness here. And if we have more story time later, maybe we can do the dynamite story. There's a tank story We could do a tank story. I mean, there's also stories about me. Nobody wants those, but that's fine. My grandpa was way cooler. All right. Math Monday. So, oof, my tablet is all messed up. Hold on, friends. There we go. Math Monday. The best day of the week. And Emma B, you say your sister is trying not to laugh. What else can you do? I know, sometimes kids, it's just, what are you going to do? Like, this is definitely not the right answer. And Kachi Zeros, hopefully, yes, we'll have time for all kinds of stories. All right, so let's see here. What did we talk about last time? We talked about variables, functions, negative numbers. So let's kind of review a little bit. So folks who are new here can catch up a little bit. And Nick 12ZZIT, welcome to stream. We talked about dog food. I've got more dog food math problems for you because I'm clearly unimaginative, and I was sitting there like, all right, I keep waxing eloquent about how math needs to be applied. So, and literally all I could think about is, okay, if Hubble eats like 12 treats and has 2 cans of food, and like literally, that's all I could think of. And Bald Engineer, thank you for following. Welcome to stream. All right, so a little bit of a review from last time, but we talked about what a variable was. Who remembers what a variable was? Tell me all about it. Why is it called a variable? What is it? Is it scary? It's not scary. It's a fancy word for something. And what is it a fancy word for? Also, while folks are answering, I did submit my application for partner. I'm really hoping I get it because also I think it allows me to have more tier 1 emotes. I know some of the emotes right now are, they're tier 2 and tier 3. And I ran out of tier 1 emote slots. So if partner really does give you more tier 1 emotes, I'll bring everything back down to tier 1 for everyone. And maybe you say a placeholder. Okay. Why is it a placeholder? An object, something that can change. Loafbone, yeah, something that can change, something that can vary. Something that can change or vary. And also I got some feedback last time to try to make my handwriting a lot better. So all of you, I'm trusting you to keep me honest here. If I start to write too fast, if I start to get messy because I get overly excited about math, just shout handwriting at me and I will try to slow down. And let's see. Variables store information, but not sure that applies here. So we're not necessarily talking about variables in the programming sense, but variables still store information in math, just most of the time we are talking about numerical values. And Ryle term, welcome to stream. Okay, and Hulk busted, you say anything that can be represented numerically or by a function. So I'm going to take a couple of these things. So there is a relationship here to functions, but often say numerical. I like that. Quantity. Yeah, that's like a numerical quantity. That's a good way to put it. But so it's a placeholder because it could be an unknown value. It can be a numerical quantity or it can actually be a function. But don't worry, we're not there yet. We haven't used variables, well, a little bit to represent functions, but not in the way that we introduce variables. And creeping when you say it can represent different things, a number, a formula, a matrix, exactly. So we also haven't done matrices, but it can, I like somebody said an object. So like maybe a math object. Kind of like that. Yes, chips and churros coming in here. Oh, thank you. Loafbone coming in with the now we have a handwriting command so that you can remind me to write neatly. And no, Hulk Busted, don't worry at all. Like I said, all levels of math here are welcome, as long as you're genuinely asking questions or contributing and not just kind of like, showing off, you're totally fine. So, all right. Can someone give me an example of a variable? And why do we need them? Like, why do we use letters? Why not some other way? And Crystal Coder, thank you. I'm glad I like my hair too. Ooh, okay, so Cookie Factory says x equals 42. I'm going to get a little bit pedantic here. Well, I'll ask you, which part of this is the variable? Cookie Factory. Emma B, you say x equals 10. Katya Zeros, you say y equals mx plus b. Where are the variables here? Crystal Coder says x. Yeah, here's our variable. Because actually, this whole thing is representing an equals relationship, right? So an equals, it's an equation. This whole thing is, right? 42, that's a number, that's an integer. And x, this is our variable. Okay. Variable is an input. They can also be outputs, GZB. So, and in y equals mx plus b, this might be a trick question. So folks who feel comfortable answering this, go for it. If this is too much, don't worry about it. Where are the variables here? Is m a variable? Is y a variable? And real term, you say you need some advice. Let's see. Well, so you're talking about reading. So real term has a question about reading math books, reading technical books, and your mind gets tired and you kind of get a little bit zony. I have that trouble too. So there's a couple of different things there where sometimes for example, if it's possible to mark up your book, I personally have found that really, really helpful. So highlighting, if you're able to do that, underlining, making notes in the margins, but also pace yourself. Like, not everybody can sit there and read chapter after chapter of a really dense textbook. Take it in chunks, take breaks. So even if it's, you're alternating it with a practice problem of some kind, or you're just, playing a level of a video game and going back and then going, pace yourself at whatever pace your brain can take. But if I try to do things all in one sitting, I zone out too. And let's see. So, YMXB. Well, actually, so Swiku, constants. So I've actually heard mathematicians, like actual math teachers, define this differently. So my programming brain says m and b are variables too. They're a type of variable called a constant. I've also heard the argument that m and b, because they are a constant value, aren't a variable. But depending on the equation, this is an equation of a line. We'll get to this some other time. Don't worry about memorizing it or looking at it or understanding it right now. But at least in my mind, m and b can be a whole lot of different things depending on what we make y and x. So I'm perfectly comfortable with us saying that m and b are variables as well. But I've also heard people trying to make the distinction that y and x specifically are variables, m and b are constants. But I think of constants as like a type of variable. So, and Ray March, you say you always thought constants and variables were polar opposites. Well, so variables are, they can themselves be constant. So, I don't feel like they are. Yeah, and Crystal Coder says, I would think of a constant as a static variable. That's another great way to put it. But regardless, don't trip yourself up about the terminology. I've heard these words used a variety of different ways. And let's see. And yes, good. Lots more people are responding to Ralterm with more great advice and grave wisdom. Thank you so much for following. And you say, you'll try to pace. Time is of the essence, but that's invalid when efficiency is in play. So also you have to understand something. And this again might be like unpopular opinion. but you don't need to deeply grasp every single aspect that is in a given textbook. If you're doing this for school, a lot of times you come back to the same ideas again and again. So like the first time I read something, I try to get a conceptual understanding. The next time I read it, I try to go a little bit deeper. And the time after that, I try to go a little bit deeper after that. But if you find yourself getting bogged down in the details, try first for that conceptual understanding. And then you can start to focus in on areas where you think you need, a deeper understanding. Yes, Kachi Zeros, exactly. This feels like a place for someone to say semantics. And creeping, when you say isn't a constant something that is known and isn't dependent on context. So once we get to calculus, no. So that's where there's plenty of times you have a placeholder constant that you don't know the value for yet. So, and freckled science, you say, then you realize you actually need it in grad school. Exactly. So again, do what you need to do to survive, but there's none of that here. This is all about trying to understand things deeply. All right. Invincible Joe, what is 9 plus 10? I'm not sure what you're getting at, but 19? All right. And let's see here. So, and no worries, Kachi Zeros, you say you barely remember how to calculus. We're not there yet. Don't stress. Don't stress. All right. So, we talked about variables. We also introduced, let's see, what else did I talk about? Who wants to summarize? Who from last time? Who wants to tell me about order of operations? And why we don't like PEMDAS? No PEMDAS here. PEMDAS is a poop. Does anyone remember why I don't like PEMDAS, or maybe can explain order of operations conceptually? And let's see. Nope, don't tell me about like parentheses exponent. I told you all why PEMDAS is unnecessary last time. It's not the P. No, we don't need to memorize anything. Why was that? PEMDAS encourages you to memorize something, which I get it. Mnemonics sometimes can help you, but there's no need, because it just encourages you to memorize a rote process instead of deeply understanding what's going on. So what's going on with order of operations? Why do we do it? Why do we need it? And girl with box, all my homies hate PEMDAS. And hi, Icy Yogi. No worries. It's good to have you stop by. So does anyone remember it? It's okay. We can go through it again. You need order of operations, but you don't need to memorize it. And PEMDAS encourages that kind of memorization. Why do we do exponents before multiplication? Why do we do multiplication before addition? Why? Because it's PEMDAS, because it's order of operations, because that gets us the answer. Those aren't answers. That's not a reason why. Why do we do things in this order? And Jeremy, thank you so much for following. Oh, thank you, Lophone. Yes. So I do a deep dive into my feelings on PEMDAS in the first Math Monday. Okay. So, and no worries, folks are, Def Hacker says, good point. I had to remember PEMDAS, but no one really explained the whys of it. And Guppy, you say biggest operations first. Is parentheses an operation? Josu Extra 1000 XD. Thank you so much for following. All right. I'll break it down for you. We'll go through it again. All right. Let's talk addition for a second. We're going to go all the way back. Easy, right? Okay. What if I got to do that? Well, I can still, 4 plus 4 is 8, plus 4, is 12, plus 4 is 16, plus 4 is 20. But remember what I told you about mathematicians. The sassy answer is mathematicians are lazy, but the nice answer is they're efficient. We're always looking for ways to simplify, right? So nobody wants, your hand's gonna hurt. Like, what if I want to add 4 10 times? I don't want to be sitting here writing that out every single time. That would be obnoxious. So, best thing about math, we do shortcuts. And so what do? We have an operation. So just like addition is an operation, we're like, okay, we need an iterative, so repeating operation that handles when we're adding the same thing repeatedly. What do we get? We get multiplication. Okay, so then we get, and remember, we're switching from using x because that's now a variable. We're using a dot for multiplication. And, pardon me, Volcano Doc, thank you so much for hosting. And also welcome Tropical Tom. Let's see. And Hulk Busted, you say, I guess you emphasize that we don't do PEMDAS because it's like saying it works like that because it just is. Correct. Yes. And because, I found this to be the case, at least in my experience, that if I understand why something is, I often don't need to memorize it unless it's a really, really long, complicated formula, in which case we should all be allowed to look it up. But if it's kind of a fundamental, property, or it's a fundamental truth, I should be able to understand why that's the case. And if I don't, and I just have to memorize it, then I don't really understand it. And I'm just like you. For the longest time, I just was taught PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. But I constantly had students getting confused. Do I do multiplication always before division? No. Do I always do addition before subtraction? No. Well, why? And that is the greatest thing, by the way, about teaching very, very young learners, is that they love to ask why. And it infuriates a lot of people because eventually, you don't know the answer. But why? Why do we do exponents before multiplication? Why do we do multiplication before addition? So I'll tell you. Well, it doesn't, the story of order of operations in general doesn't stop here because, we like to do things over and over and over again. So I'm going to switch to some smaller numbers because I'm really, really bad at exponents. But let's say, now we're multiplying 2s. So again, we run into the same problem that we did with multiplication. Yes, we can sit here and go, okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But again, what if I want to multiply something 50 times by itself? My hand's going to fall off writing all of that multiplication, so we need a shortcut. And for that, we have exponents. So, I'm going to just give myself some more room here. All right, why do we have to do exponents before multiplication, before addition? So if I have... let me write this larger and also in a brighter color. So, if I have this, right? Think about it. This is a placeholder. What is this a placeholder for? This is a placeholder for iterative, repeated multiplication. Okay. All right, now we're getting somewhere. Well, what is multiplication? It's iterative or it's repeated addition. So we've got, oh gosh, I'm going to screw this up. Hold on. And then we got to do that 3 times. See why we have the shortcuts? And I'm running into my head. I know. Give me 1 second. All right. Now we have addition, and we can figure out what this is. So, but look at this. Oof, that's tough to evaluate. That is tough to get a value for. And so certainly all of us now look at this, and it's a lot more intuitive. But why is it intuitive? Because we have learned that exponents are just a placeholder for multiplication. Multiplication is just a placeholder for addition. We can't add 3 plus 5 here because this times 3 here isn't addition. We have to expand that. We have to untranslate it from the shortcuts, from the abbreviations that we've used. Exponents are an abbreviation. Multiplication is an abbreviation. It all comes back to addition. And so here, all right, let's see. 2 times 2 is 4 times 2 is 8 times 3 is 24 plus 5 is 29. Hopefully that's right. Kind of did that a little bit in my head. And I'm not good at arithmetic in my head. But hopefully this makes a little bit more sense. Don't just memorize PEMDAS, right? This is about, okay, in math we have these operations that are useful, division, multiplication, exponents, but they're shortcuts. They're shortcuts for something else. And so we can't just combine everything willy-nilly. We have to kind of expand out our abbreviations first. And again, who wants to do this though? Nobody wants to sit here and write this many 2s. This is an absurd number of 2s. So what do? We say PEMDAS, order of operations. Remember to do your exponents before you multiply. But what that's actually telling you is expand it first. Translate this first so you can combine it with something else. And Raymart, you ask, what about the P? So, and this is another problem, okay, is that parentheses can mean different things in math. So when we have PEMDAS, not only is that not true, half the time I used to teach SPEMDAS, which is resolve your signs before you do your parentheses or anything else. But like, what are we supposed to do? Try to create an acronym for every possible mathematical scenario? No. Teach the concepts. So there are, and I'm doing this on the fly, so I might have missed something. So for now, and I'm putting an asterisk in this that I can come back and revise this, there are 2 kinds of parentheses I can think of off the top of my head. 2 uses for parentheses. Okay? So before I even answer your question, Ray Marsh, let's take a look at what parentheses do. So in a case like this, actually, let's do that. Parentheses here are a little bit superfluous. Those of you who know your properties will kind of know the parentheses aren't doing much here, which also means, guess what? You don't have to do your parentheses first here. Doesn't matter if I do 7 plus 5 or I do 9 plus 3. It's 12. So what, is PEMDAS broken? No, it's just that it's very, very conditional. So this is a parenthetical, parens of I would say grouping. So that's one thing that parentheses can do for us, is that sometimes it's not so much mathematically necessary, but it helps with the readability of our math. Like maybe, I want to, oh Lord, let's come up with an example on the fly. Let's figure out, maybe I have, how do I want to do this? Give me a second. Coming up with an example in my head. So let's say I have, let's say there's a weight limit in my car. And I've got a lot of bags of dog food. So I've got all my dog food. But also I need to consider that my dogs are going to be in the car. So maybe I write something like this. Now, this isn't a grouping that has to be here because otherwise I'm going to get the wrong answer. I don't have to add Hubble and Tennessee's weight before I add the weight of the dog food. This is a grouping of context, really, that to me I'm grouping Hubble and Ten together because they're dogs. And so I'm like, okay, these are similar, so I'm going to group these mentally and keep them separate from the dog food. It improves the readability. And if you actually do a lot of physics, you'll see that this kind of grouping parentheses are used quite frequently. It helps your readability. If you are a programmer, you'll see people doing this as well. It helps you read the code. So that's one thing we can do with parentheses. The other thing that we can do is that parentheses, remember how I said we like efficiency? So we might have something like this. Well, why do we need the dot? It's kind of like how either you want to say, instead of saying do not, you say don't, and you get the apostrophe, or just over time, how sometimes the faster and faster you say something, you kind of drop the end of the word. Similarly, you'll have kind of parentheses that indicate multiplication. And this is where you have one value that's kind of all snuggled up to the edge of the parentheses. And that, or the parens, excuse me, and that indicates multiplication. So you don't always do parentheses before. Like sometimes you do with grouping, but it depends. In this case, you don't have to. In the case of, this you do. So this is less grouping, and this is more making it really explicit that I know normally we should expand our multiplication and, do that first, but here you've got two values in here. But those of you who know the distributive property know that we don't have to do what's in the parentheses. We can distribute the multiplication. Why are parentheses at the start of PEMDAS? It's more about understanding the context and the different ways that parentheses are used. Okay, I have so much chat to catch up on. I'm so sorry. I wanted to get through that explanation. So let's see here. GY Marcelo, you ask, American students learn calculus in school. I think it depends. Some students do, some students don't. And Nateo, you ask, you're in Algebra 2, you say, what of the quadratic formula? What about it? What about the quadratic formula? And Girl with Boxy, like translating a word problem. Exactly, right? So we use shorthand, we use abbreviations all the time. We use it in human language, we use it in programming languages, we use it in math. Like the more efficient we can be, the better. But also, if any of you work in business or consulting, like me, sometimes acronym confusion is a real thing. Like, I've seriously sat through meetings and been like, I know these acronyms from the fire department, but I'm pretty sure that's not what they mean. So the danger with any kind of abbreviation is that you lose, you might miscommunicate. And so instead of communicating and explaining what the math acronyms mean, we just teach people PEMDAS, which ends up causing more confusion because it isn't always true. And let's see, Suto Daniel and Fikapua, thank you so much for following. Welcome to Math Monday. And yes, Leaf Bucket, one of my dogs' name is Hubble. The other one is Tennessee. And no worries, Kachi Zeros, I think you have to leave. No worries. It's good to see you here. Off topic, but I love Hubble so much. Well, have no fear. If we get some dog treats going, we'll have a dog treat break. So snuggle up means multiply. I thought this was math. Well, if it's pressed up against the parentheses, it's multiplication. It's a little bit of a snuggle, I would say. And Natalia, say you're learning it, but you don't understand. Well, we will get there. We're not there yet. So first snuggle up, then multiply. We are not there yet, but hold on because we'll get there. We'll get to the quadratic equation and beyond. And all right, so let's see here. All right, I've gone on my ramble about PEMDAS. We have reviewed that. This is a lot of pluses. I wonder if I can move these. Close enough, just so I have a little bit more room here. Okay. All right, so we've reviewed variables. We've reviewed why PEMDAS is not the thing that you should remember. Parentheses for multiplication and chill. Yeah, see, I knew somebody would have much better puns than I would. Very nice, the real Pygon. All right, so what else did we talk about last time? I'm looking back over my notes here. We also started to learn some really basic functions. So who wants to talk about functions? And Girl with Box, you say you still get some of those viral PEMDAS problems wrong because we learned it differently in Jamaica and it's still subconsciously there in my head. How did you learn it? I would love to hear that, because also, again, just like with acronyms, right? Like if we're not teaching the fundamental concepts and instead we're teaching a shorthand, unless that shorthand is effectively communicated, you can miscommunicate. And DEFCON 201 Live, thank you so much for the host. Welcome, welcome. Yes, let's do functions. Exactly. And I know Apple Glass, I love this pen so much. I was actually trying to figure out, as silly as this is, some way that I could use this pen to do like pretty overlays for the stream. I'm not like a designer or an artist, but I've been wanting some nicer overlays. And I just love this pen so much. Okay, so let's see here. Functions. Let's give ourselves some room. What are functions? And again, remember that we're trying to understand the concepts here. So how would you describe a function conceptually? I don't want like, given the set of, none of that. At least not yet. Well, we might get there, but not for now. And Julio, you say, I don't understand. Is that the secant? I think that's the abbreviation for secant. We'll get to trig. Stay tuned. We got to start somewhere. You learned BODMAS, bracket of division, multiplication, addition, subtraction. Oh, see, like that's, again, like there are so many different variations on PEMDAS as well that I would much rather people understand why you do those operations in that order, because next time you see it, it'll feel more intuitive. It is secant. Yeah, we'll get to trig. And let's see. Leaf Bucket says something that takes an input and generates an output. So that's one way to think of it. Okay, so we take an input. Generate an output. How do we generate that output? And what else? What do functions tell us? So creeping when you say a formula that transforms a given input into an output such that the same input would yield the same output. Simplify that. Yes, Swiku's getting at one thing I want to touch on, which functions map a relationship. Map or define or describe. Describe a relationship. And what is the relationship between? And Martin Eden, yes, they generate an output according to a rule. What is our relationship between? And let's see, Nicero, thank you so much for following. And Stream Dog Cam, I know, so I have a Furbo, which is a dog treat with a camera thing. And I pull it up on stream, usually, so every 100 bits, we bank a dog treat, and then we take breaks, and we give the dogs all the treats. So, let's see. I should make like a stream redemption, though, if I ever get a dog cam. But the problem is that my dogs are always all over the place. So unless there's the treat to like tempt them in, you might not see anything. So, okay, let's see. All right. What are we doing here? They map, define, describe a relationship between what? What are we describing a relationship between? Or, what does the relationship have in it? Like, oh no. There we go. And Reboot, thank you, 2 dog treats. All right, Lowphone, you got to keep track of the dog treats tonight. Suiku, you say independent and dependent variables. That's very, scientific method. I like it. So yes, a lot of times these functions, we're going to have at least one variable. And, we might have those constants that we talked about before. Between... Let's make this broad. We'll just say values and variables. How about a soy patty with a what? People talking about delicious food. Now I'm going to get hungry. So one of the things I miss so much about the pandemic is that, like, my favorite restaurants, a lot of them aren't doing delivery. So I have not had Ethiopian food in over a year. And like really good Jamaican braised oxtail. Like, just, I'm suffering here. And I'm not like, actually, I don't think I've ever cooked oxtail myself. And I think you need a pressure cooker. Yeah. Ugh, I miss it. I miss good food. All right. And Martin, you say this is like Python's dict structure, right? No. I would say no. But we can talk more about programming stuff another time. All right. So let's see here. Yes, all the love in chat for oxtail. It's so good. It's so good. No hungry. Hold on. I'm going to drink some more water. Okay. Math, not food, Jess. Got to focus. Suddenly now all you all are going to be getting random functions involving food. Okay, so how many plates of oxtail can Jess eat? I know. Stop talking about delicious food. So here we have decent Indian places that deliver. Decent Thai places, no Korean places. So I haven't had really good Korean food in a while. Just there's a lot of food I love food. So missing out on that due to the pandemic. Entropic Universe, welcome. All right. So really though, what I want you to take away from functions is this relationship here. I guess purple. Because that's how, at least, especially in the start of algebra, we're going to be talking about relationships between values, because that's going to kind of motivate why do we even care about functions in the first place? Well, they describe a relationship, and most, if not all of our jobs or things we study are examining relationships of some kind, whether it's a cause and effect or two things and we want to know how they're related. And I mean, this could be anything from, philosophy all the way through your hard sciences. A hacker, you say, I better be ready for story time in 15 minutes. I got you. Nomnies and T-pose. Thank you so much for following. So that's what I want us to focus on for today. So when we look at something like, guess what? You're getting another dog example. If I say, okay, who cares, right? That looks like whatever. Well, let me expand it. What I'm saying here is Hubble's weight is equal to 2 times Tennessee's weight, roughly. Well, nobody wants to write all the letters out, so of course we're going to abbreviate. Like always, we're going to be efficient and use a shorthand. And in this particular case, why might I care about this? Well, if one of my dogs gets sick or maybe is eating too many treats or something, I might notice that suddenly Hubble's weight is more than 2 times Tennessee's weight. And that might be, maybe I model their weights like this and I keep track of them. And when I see something deviating too much, I'm like, uh-oh, this isn't good. Like, I want to hold fast to this relationship. So there are lots of different reasons that we might want to model different relationships. In stream, it'll largely be involving dogs because that's the fastest thing that comes to my mind. And let's see. And Techrific, you say you think about it in terms of spaces. You say we have an x value in one space being mapped to an output f of x in another space. So I could see kind of what you're getting at a little bit. I think so. If I can show an example of that. So one of the things we talked about last time is how to look at values on a number line. And if I have, let's say I've got, well, we'll use some real weights here. So Tennessee's about 30, well, we'll say 35 pounds. and Hubble's about 70 pounds. So if this is Tennessee's weight, 10, and this is Hubble's weight, Hubs. Well, yes, our function is mapping these two things together, but when I illustrate them like this on two separate lines, you don't really get a sense for the relationship so well. And so that's something else that we talked about last time, is that one way that I can show this relationship visually is, let me think about this. If I have, 10's weight here, we've got 35. So we'll put zeros way back here. And so let's say this is 35. And then I'm going to take Hubble's number line. Goodness, forgot the word for number line there for a second. And I'm going to rotate it. And suddenly, I have a way to illustrate that these two values are connected. And we're going to get more into graphing later. But I kind of like what you were saying, Techrific, because it is mapping two different spaces, but also when we start to think about planes and things like that, you can have planes, spaces, that are defined by a given equation. And so I'm going to, this might sound, if you don't know what I'm talking about, don't worry about it. It's a little bit beyond what we're doing right now. But to that extent, both of your variables exist in the same space. And so I would hesitate to use that term, but I think I see what you're getting at a little bit. Also, space. Exactly. All right. And 40s Gamer, welcome to stream. Thank you for following. And hi, Caesar88. Welcome. Amount of food is 2 times bigger than poo. Oh, goodness. That just reminds me of how much poo there is in my yard right now. Flanger Morning, thank you so much for following. All right. So, and Speaker, you say, are functions also the boundaries applied to them too? What do you mean by that? So, we can apply boundaries to functions. We haven't done that yet, don't worry, but we can apply boundaries to functions. And those boundaries, depending on the type of function we have, could be very complex and almost be like functions themselves. Is that what you're talking about? I want to make sure I'm answering your question. I didn't quite follow what you were saying. And let's see, catching up more on chat. You see a bits, how do I donate them to give treats for Hubble and 10? Okay, well, Loafbone's on it, he'll explain. Chat trying to nerd snipe. It's fine. I'm getting better and better at handling tangents. And Crystal Coder, Pooh Yard is the Minesweeper game? Oh, yeah. Well, when Hubble really loves his Frisbee. That is his favorite toy. I better actually say that kind of quietly. His Frisbee, as we have to say in this house. And when it's been a little bit, or there's been a lot of snow, so it's been really hard to pick up the dog poop, going outside and throwing the Frisbee for him is a bit like Minesweeper. It is. Ray March, coming in with an excellent pun, you say, I knew as a mathematician you'd be good at handling tangents. Hey! All right. So let's see, we've talked about functions. All right. Let me see how my notes are doing and where. Ooh. We're gonna do a little bit of cleanup here just for a second. Friends, before we start the next. Oh, what? I wanted to move you. Oh, I think I have to, hold on. I think I have to grab the place where they all overlap. Here. No? Okay. You're not gonna let me move it? Do I have to use my mouse? Sorry, hold on, friends. Let me move it? Yes, here we go. Just trying to make my notes a little bit neater for you. All right, there we go. So, now let's go down here. No. Just 100, please. Oh my God. This annoying. Zen. Come on, you're never this annoying. Come on. Oh, I give up. What? Oh, close enough. All right. So, I want like my handwriting to be consistent at least, but all right. Let's see. Emma B, you say we have to spell out, well, we have to here. So you have to spell out W-A-L-K or the puppy goes nuts. Yep. That's another word we have to spell out. We also have to spell out T-R-E-A-T. That's another one. And we abbreviate day camp as DC because if Hubble hears that word, I can't control it. It's just a scroll wheel unless... There you go. Look, it just took one more try. All right, whatever. Sorry, chat. I was like, it's close enough, but I will try to be perfect for all of you. Okay. So I think that is a good summary of what we talked about last time. We also went over negative numbers. I'm not going to dive as deeply into those. If you're interested in that, also in an explanation for why multiplying two negative numbers gives you a positive number or why those operations with negative numbers work the way they do, check out last week's Math Monday video. And Neo Qua, thank you so much for following. And let's see that math teacher. Hi. No worries, lurk away. Lesson planning, good Lord, you know? that's far more important, but thank you for being here. All right. So, let's see. Def Hacker 200 bits. Yes, thank you, Space Bay. So now we've got, I believe, four things banked for the dogs, four treats. Wonderful. We will take a break. Let's see. When will we take a break? Let me get through just a little bit more, and because there were a couple more things I wanted to talk about today. Obviously, we just did our review, and then we'll give the dogs some treats. All right. So we reviewed variables. We reviewed functions. Everyone, do you feel good with the term linear? That's also something we talked about last week. Remember, linear being line. So when we have our functions describing a relationship that is a line, those are linear equations. And so we're going to talk a little bit more about those today. And so again, I feel like this is a term that's thrown around, linear equations, systems of linear equations. Line equals. So we have a function, we have an equation, right, that has an equals relationship. We've got an equal sign. And the shape of that relationship is a line. That's all this is. Complex numbers. We'll get there too. I love talking about complex numbers. But I remember, especially when I was doing like periodic motion and stuff in physics, that there was just like, I had a brain block with complex numbers for a while. I was like just deeply bothered by them. And then, I don't know, the more that I did that and some of the really cool stuff you could do with like Fourier transforms, especially with radio telescopes, it was just like, so cool. I got taught them terribly too, Ray March. So that's going to take me, I'm going to have to like sit alone in my office and think deeply about like how to do it right. Because they are taught terribly. It's another one of those, just, memorize it. And you're kind of like, what? All right. Hulk busted Fourier transforms. Yes. Actually, been using them a lot lately as well. Any kind of signal processing, you're probably going to use a lot of Fourier transforms. And Martin, you say linearity always implement straight lines. Yes. So these linear equations, the one we're going to be talking about today, yes, we're talking about straight lines. Story time inbound, a hacker. Okay. Well, I'll give you a couple different topics you can pick from. Okay, so what am I talking about when I say linear equations? And remember that last time we did see this notation, f of x equals stuff, but I kind of said, that's really just a way of saying y. And this is kind of like, the function you're inputting the x, it's nomming the x, it's going to spit out an output, a y. Later, we might need to use this when the math gets more complicated, but for now, we don't need to worry ourselves with that. If you see that f of x, though, in the context of what we're talking about, for now, you can think y. And floating storm, thank you so much for following. I don't know, Ginny Liz, it always looks like that to me. Like, this just looks like a mouth, and it's just eating the x, and if that helps you remember what f of x is, go for it. All right. So, if I have something like, actually, let's not even, we're going to put Mr. Y on a shelf for now. Let's not even deal with that. Hi, Non-Dairy Neutrino, how are you? Let's instead deal with really, really basic equations. So let's first go, before I even do linear equations, let's start with a slight subtopic here. So I'll use the rainbow pen instead of the space pen. There we go. Which is, let's talk about single variable. Ooh, this one is like intense. Can you all read that? I can rewrite this if this, it seems very intense to me, but hopefully you can read it. If you can't, I have no problem rewriting it, but that's a little bit like, whoa. Kind of looks very similar actually to the space one, just the sparkles have a higher density. Okay. Or a cat butt. Oh goodness. Don't summon the trolls that I had yesterday, please. We got some very disturbing ASCII stuff. So they've been banned, but let's... Okay, a hacker's redeemed story time. All right, before I get into single variable stuff, we'll do story time. All right, a hacker. Let's see here. You can have... Let's see. Tank story. You could pick two if they're my grandpa stories, because those tend to be a little bit shorter. A tank story, the soap story. Or Hitler's surgeon, that story. Those are do you want a grandpa story or a me story? I should have asked first. I know. Derailed, but it's a redemption, so I have to be derailed by a redemption. I've got to honor my wonderful community. So it is a hacker's choice as to what we choose. One dynamite story. I missed that. Okay. Oh, haha, Loafbone. Oh my gosh, that actually tricked me for a second, because Loafbone often highlights people's messages. A hacker, it is your choice. We can do a grandpa story, and I just gave you the options. If you want a me story, I can give you some more options as well. Usually the me stories, I'd have to think a bit more about those. But you want dynamite and soap. Okay, all right. So those are the same story, actually. So if you want to pick one more grandpa story, go for it. All right, so it's a bit of an adventure. Okay. So when my grandfather was very, very small, probably, I think he was younger than the cannibal story. He's doing what young kids do, which is like what I did when I was, 7, 8. It's just you kind of explore, right? And you get into trouble. You like climb all over stuff, the world is your oyster. And, it's funny sometimes to go back to those places. For me, at least, I went back to what I remember as a child being a wild, massive bamboo forest that I had the most amazing adventures in. I drove past that house just a few years ago. It's like 20 feet of bamboo, but to me, it was like this mystical wonderland. And that's what my grandfather did, especially kind of living in a more rural area, is just all of these wonderful adventures all over the place. And, one day, he comes to a bit of a stream, I would say, larger than a creek, and there's a bridge over it, and probably a river, actually. Now that I think about it, it's probably a river. I don't know, let's not get pedantic. There's a bridge over the river, and he's, playing in the puddles, splashing away, having fun, and he sees a bunch of soap. Now, soap was a luxury. So he is sitting here like, my mom is gonna love me. This is gonna be so great. There's like soap for days. And so he and his friend just pile the soap up in their arms and they go like hightailing it back to the village to tell their moms all about this. And, arms full of soap, slippery soap, like it's probably a wetter area. And they are just booking it for the village. And, oh no, Deaf Hacker, the captions broke. Let me know when they're back. I want my stories to also be accessible. I will wait. The captions broke. Let me make sure. I can try to refresh them. Let me know if they're back. They did break. You're absolutely right. Testing. All right, they should be back now. Deaf Hacker. So I will rewind the story a little bit. But all you missed was that my grandfather was exploring and he came across a river with a bridge over it. And he and his friend were playing in that river and they found a whole bunch of soap. And soap for them, especially, during this era of rationing and wartime, soap was a luxury item. So they were thrilled. They were probably more enthused, I feel like, than your average 7-year-old would be today if they found bars of soap. So like loading up their arms with bars of soap and they start sprinting. And I remember that about the stories. My grandfather always emphasized that he was running, arms full of soap, back to his village. So excited to show his mom. And luckily enough for him, there was an adult in the road who took one look at them and started screaming and saying, "Stop moving." And he and his friend were like, the hell is this person's problem, right? So they stop though, because if someone screams at you, you're gonna stop. They stop and the person is like, "Do not move." Grandfather's like, "What's your problem? Like, we just found all the soap, we're bringing it back to, the village." And the person looks at them and says, "That's not soap, that's dynamite." And yes, my grandfather had piled his arms full of dynamite and was running back to his village. And luckily enough for him and his friend, this person stopped them and they were able to very, very carefully unload the dynamite and dispose of it safely. So yes, my grandfather almost died so many times. I mean, he passed away near the end of last year, unfortunately, but there were so many chances he could have died before the time that he did. So my grandpa wanting free shit almost got him killed twice. All right, and you picked the tank. So another encounter. All right. Similar kind of grandfather being too curious for his own good kind of situation. Again, exploring, climbing all over stuff, looking to stuff. Well, there was what everybody thought was, an unused, broken down, non-functional tank on the outskirts of the town. And of course, the kids were forbidden to go anywhere near it. Did my grandfather listen? Of course he didn't. And so my grandfather decides to approach the abandoned, theoretically non-functional tank and climb inside. Now, this had been looked over by adults. They had, deemed it non-functional. It wasn't working. My grandfather, in all of his 8-year-old wisdom, somehow found a way to turn the thing on. He turns on this tank that everybody thought didn't work and starts spinning the turret around, probably laughing and having fun, thinking it's all a game. Well, there happened to be, a small contingent of soldiers going by, and they noticed this tank, turrets kind of going and everything, freaked out, retreated, ran off, and my grandfather, when he told this story to me, said that he still remembered to that day the fury in his mother's voice, because she knew it. Like, I feel like, you know, my babushka, she had to know, like, this was her son. If, like, yeah, just, she knew her son. So she, you know, the soldiers ran off, but this woman was fearless, is like marching up to this tank, like, hell hath no fury like my grandfather's mother. And just the way she said his name, he said he still remembers just that, like, cold fear of, oh crap. And so while I'm not, you know, supportive of corporal punishment for children, he did say that he still remembers getting quite a bit of a spanking for turning on a tank and spinning the turd around. To this day, he doesn't know if there was actually any ordnance in there. So there you go. And also, I've missed some follows. We're in the middle of story time. So Floating Storm, Pikaya XY, Nazmal Wanted, Cloanic, and Bash Bunny. Welcome to Math Monday. We had a little bit of a redemption for story time, so I was telling some grandpa stories, but we'll get back to math momentarily. And this is not in the US. This was in Ukraine. Tiananmen Square, Ukraine edition featuring my great-grandmother. You know, she, like, I actually got to meet her. So she lived until her, like, late 90s. It wasn't COVID, thankfully. He had been in congestive heart failure for, like, 10 years. And honestly, we had so many scares with him where I think the family just kind of thought he was indestructible. Like, even in his 70s and 80s, like, he would have these moments where the doctors would tell us, like, this is it. And then, no, he was like this most stubborn human being on the face of the planet. And so he would just be like, hell no, I'm not ready to die. And he would just recover entirely. But, so it was super, super fast. He just woke up one day and was having trouble breathing. I thought COVID, so I was really concerned about that. But within a few hours, he was on a ventilator, and they said, you know, his heart from the congestive heart failure. So, but 2020 was a crappy year. He was a force of nature. So he came to the United States at 18, didn't speak a word of English. Started out getting a job as a dishwasher, eventually taught math and physics. So I actually have some of his, after he passed away, he left me in his will all of his math and physics books. So actually, I've shown this on stream before, but one of them I keep in my office. This is from, let's see, this is from 1878. So there you go. But really, really cool math book. So, and I've got like some of his handwritten notes and everything, which is really, really nice. But yeah, he was a force of nature. Oh yeah. And then, after all of that, becomes a priest, then eventually becomes a bishop. So yeah, he's had a wild life. And Dust NZL, welcome to stream. Don't you dare blow up those soldiers or you're grounded. Parenting problems I will hopefully never have to face. Goodness. Kevin Dawson 13 and Ryan 1630, welcome to Math Monday. And I'm so sorry to hear about your fur baby Deaf Hacker. I have immortal dogs. That's the only way that I can adopt and have them, is that I have to partake in some cognitive dissonance, or I would just be crying all the time. So I don't cry about many things, but since adopting a dog, I cry about dogs dying in books or movies or anything like that. But mine are immortal, so never have to deal with that. All right. From math and physics to religion. So Swiku, if you understand, I think, Russian and Ukrainian culture, like faith, and specifically the Russian Orthodox Church or Ukrainian Orthodox Church, is a very integral part of the culture. And so especially given the time that he was raised in, I mean, he literally taught math and physics in a seminary for a while. So he, that was, it was always a very integral part of his life. And I will say this for him is that, you know, a lot of people are like, oh, people are products of their times. And he was very, very conservative. But I was raised Russian Orthodox. And when I used to chant in my parents' church, we went to visit him with his parish in New York. And I was like 11. And so I was doing the chanting or something. And a bunch of parishioners started to make a stink saying a woman's voice should not be heard in church. And he stood up for me and was just basically like, shut up. Like, shut up. And so even though he was very, very conservative, I still remember that and how great that felt. And I'm not religious anymore, but those are still some really great memories. Raw Yolks, thank you for following. All right. We've had some good story time, but let's get back to math. As my grandfather would probably be scolding me if he was here. Stop talking and do your math. The one thing I regret maybe a little bit is that, so he actually taught me math. I was homeschooled for 4th grade and 7th grade, and I gave him hell. I fought him on everything. I hated math. So there was a little bit of sort of like a, I don't know, come to Jesus moment where I had to go back and be like, yeah, so about saying I hated math, I'm going to grad school for astrophysics. Hey. So there was definitely a moment there where I had to kind of, you know, have my humility. But reboot to you. Thank you so much. I think we are up to, what are we up to in terms of Dog Treats Loafbone? Let me know. All right, so let's get back to our math for at least 50 minutes, I guess, a hacker. Maybe I should make the redemption a little bit higher. But let's talk about single variable equations. So let's start off really easy as a review, right? So if we have something like this, I think it's, 6 or 8. Okay, well, we'll say 8. Why not? We'll round up. We all have an intuitive sense. If I say, Hubble gets 5 more treats than Tennessee and Tennessee gets 7, or Tennessee, let's see, no, I did that reversed. Let's say Hubble gets 5 more treats than Tennessee and Hubble gets 7. So how many treats does Tennessee get? Intuitively in our mind, we're like, okay, well, 5 less, right? So 2. But really what we're doing there is we're subtracting this 5 from both sides, and we get 2. Now, there have been a lot of questions. Smallsy! I see. Hi! How are you? Please tell me you slept. Please tell me you slept. It was like 2 p.m. my time, and you were streaming, and that is not a good situation. That means it's like 6 or 7 a.m. for you. So I hope you got some sleep. Welcome to stream. In reverse mode, you say, I'm done. Thanks for the math lesson. Gotta go grab your graduation certificate. I don't know if you're being sassy or not, but if you are grabbing it, congratulations. Have fun. Okay. But there were some questions last time about okay, balancing and why are we doing it to both sides? That seems really prescriptive. And so, I was playing a game before stream, and it was a game I'm going to do a terrible job here. So it was a game where you have a balance, right? Well, it was one of the puzzles in the game, but still, oh gosh, that is horrible. No one sees my shame. Switching colors. All right. That's a little bit better. All right, close enough. All right. So you have a scale, right? And then you have some weights that you can put on the scale. And so, in the game I was playing, maybe this one is worth 2. But this one had like a spiral kind of shape on it. This one had a triangle. Then there was a little bit of a small one that had a 1 on it. And you were supposed to figure out what like the spiral, and there were a lot more, but I'm going to simplify. And you had to figure out kind of what the spiral and the triangle were. And there were a lot of different ways like you can do this, right? So you might think, okay, so if I know, for example, if I've figured out, you know, through my unparalleled powers of deduction, that this spiral weight is equal to 3 because I put the 2 and the 1 here. And they're balanced. They're equal. Well, if I take this 1 off, they're not balanced anymore. The spiral doesn't equal 2. It's not the same weight. So I would have to find some way of like shaving off, you know, a value of 1 from the spiral weight in order to make them equal again. So I think we've done problems like this. If you've done a puzzle game, you've probably done some kind of problem like this. What you've done is algebra. Literally, this is algebra. Just because it's a spiral and not an X doesn't mean that's not algebra. Just like in this, when I take this 1 off, I've changed the relationship because a balance here is just an equal sign. We're saying these are the same, which is the same as weighting two things of equal value. They're the same height because they're equal, an equal sign. So even if, you know, we have X here equals 2 plus 1, that is the equation describing this puzzle. But if I take away this 1, suddenly this equals is broken. It doesn't hold anymore. It only holds to keep it balanced if we do the same thing to the other side. And so that's really the motivation behind why we do the same thing to the both sides. It's not a prescriptive rule. It's that this equal sign is establishing a relationship, right? It's establishing an equals relationship, equivalence between two things, whatever's on the left side and whatever's on the right side. And so when we start messing with that, we have to. We're going to mess with it. It's going to be fun though, you know, because maybe we're trying to figure something out. We have to keep that balance. We have to preserve the relationship. If we start doing something to one side that we don't do to the other side, our scales are going to become completely imbalanced. And Program with Dan, thank you so much for following. And you say you've done this on Facebook. I've been playing, I love puzzle games, and I see like these kinds of puzzles a lot in puzzle games. So, and Reverse Bug, you say, why use a spiral instead of 3 though? What is the usage of algebra? Is it to reduce multiple digits into a single character? So not so much. It's in this game, they put a spiral on it because it basically represented an unknown quantity. I didn't know how much this weighed in the puzzle. I had to figure it out. Well, we're all mathematicians now, and we know what the math word for an unknown quantity is. It's a variable. So if I were to translate this puzzle into math, this, you know, before we even started, we could just call this X. We could call this spiral. I don't care. You want to call it spiral? Let's call it spiral. We got spiral plus 5 equals 7. I don't care what this is. It is a non-number because numbers would confuse us, right? We need something, a symbol. It doesn't matter if it's a letter or a symbol you make up. I don't care. A lot of times, just like with variable naming and programming, it's wise to be smart, like using variable names that you know, help you understand what's going on. So it would be really confusing if I was talking about Hubble in Tennessee and making an equation and I use T for Hubble and H for Tennessee, right? So we try to be wise with our symbols, but it's just a symbol. I don't care. We can do a whole bunch of algebra with spirals if you want. We need a Jess math emote. What? And puzzle games are the best, Mushini. I agree. So with that in mind, with this like puzzle game, we're balancing, right? Let's like kind of walk through a couple of these. So what about, and this is just for let's see, this is for you, Reverse Bug. Here, reverse bug. I'll make you a bug. I'm not an artist. Don't be hating. Give the bug. We'll give the bug some spots. Maybe it's a ladybug. All right. Bug minus 4 equals 22. So what do we do here? Well, we want to know what bug is, but we have this minus 4 here, right? So we want to, it'd be like if I had spiral here. Well, actually, I'll do it. Let me fill this in for all y'all. Hold on. So what we have here is we've got spiral, and we've got 22, and got minus 4. Well, this isn't helpful because we just want spiral and we want whatever it is over here. So we don't remove the bug. But we need to get rid of this. And get rid of this in math, you can think about like, well, how do we get rid of something? What is our math value for a lack of, like, a nothing? Well, it's 0. So if we think about our number line and we think about 0, how do we get there? 1, 2, 3, 4. We add 4, right? So let's get rid of that 4. Let's make it 0. But because we are keeping in mind our balancing here, we have to do the same thing to the other side. And that gives us my terrible drawing. Oh my gosh, I did. It's like, wait a minute, something's not right here. That's because I'm talking while I'm doing math. Multitasking. And we get bug is 26. So, debug, haha. But, so it's not just, oh, you have to do the opposite. Well, why do we have to do the opposite? I hate that. Why do we have to do the opposite? Well, we have to do the opposite because we want just the bug. And if we're adding or subtracting, the only way to add or subtract something and just make it equal to the bug is 0, right? So this is something you might hear called the identity property. I don't like people memorizing property names. I'm giving this to you if you're curious. But we are exploiting something called the identity property. Think of addition, additive identity property. I don't know. I don't even remember if this is the right name. It's something like this. The point is, this is asking, what can we add or subtract? Oh, I need a handwriting check here, don't I? I am so sorry. Let me rewrite this much better. I'll do it in a more fun color too. Let's switch up our colors. Ooh, I haven't used yellow. Identity, property, I believe this is what it's called, of addition. Okay, and what is this? This is answering the question, what can we add, or, am I running into my head? No, subtract from a number and get that number. So the way that I like to remember this, identity, you're getting the same thing. So the identity property of addition is saying, what can I add to something and not change it? It's identity. Your identity, doesn't change. We're not going to get into philosophy here, but what can we add or subtract to something and get that same number back? Well, the identity property states that's your identity property, that if you add x plus 0, you get x. So here's your, language description, here's your math. Don't worry so much about memorizing the name, but know that what we're trying to do here is we're trying to do something that gets us the bug back. We just want the bug. We don't want the bug -1. We don't want the bug ×5. We just want the bug by itself because we want to know, okay, bug equals what? And so we need to figure out some way to go from -4 to some kind of value. Like, this is what confuses a lot of people, I think, is that we're not making this -4 disappear. We are turning this into ±0. We're turning it into 0. We're not like, it's not, but who writes zeros? We don't need to because it's nothing. But really what we're doing here is we're trying to figure out a way to take this value and get it to be 0 because we know with the identity property of addition that bug plus 0 equals bug. So if bug plus 0 equals bug, then whatever bug plus 0 here equals is the value of the bug. So, hopefully that is, I know this is like a deeper dive. Like most people just teach you x plus 5 is, 10, you just do the opposite. I feel like that's a little bit of lazy teaching. Why do we do the opposite? What are we trying to accomplish here? Then later they tell you to memorize something called the identity property of addition, and you're like, why do I care? I just have to check this on some standardized test and remember what it means. Well, the reason why we care is that we can exploit it. We can use it. Congratulations, you've just done your first math proof, which is literally just, I'm stuck in this situation. How do I figure this out? And we used a property we knew to get to the answer. Similarly, so let's go from this addition and subtraction. Hopefully this is all, swirling around in your brain. And again, I know you probably all know this already. You're going to immediately go do the opposite. Okay, here's the answer. I'm not asking you for the answer. I'm asking you to think about it in the same terms that we just talked about. For this one, oh yes, let's do the opposite. No. Think about it. What are we trying to do here? What are we trying to do here? We are trying to get rid of this 3, right? We need to get rid of this 3, but we need to do it in a way that we get the x back, right? So right now the x is multiplied by 3. Now, we can't somehow multiply it by 0 because we know things that are multiplied by 0 is just 0. So we have to use a different kind of identity property here. What can we multiply by where we get the thing back, the same thing back? It's unchanged. So Warzoid, you're skipping ahead, but yes, I love where you're going. But what are we trying to multiply x by? We're not trying to, and yes, inverses and doing the opposite, and so much of this is ingrained in your head, but why? And exactly, Warzoid, because we need this 3. We need this 3 to be a 1. And boom, you've just taught yourself the identity property of multiplication, which is just, what can I multiply something by to get that thing back? The answer is 1. So how do we get from 3 to 1? We need 1. How do we get from 3 to 1? Well, there's a couple different ways to think about it. You can think about, what can I do to 3 to get 1? Well, you can think about it like, I can divide it by itself, right? I know that's a thing I could do. I could divide it. You can also think, if your brain loves fractions, you can remember that 3 over 3 is also 1. Well, guess why 3 over 3 is 1? Because fractions are just division. This is another way to write division. In fact, if you look at the division sign, it's a fraction. Whoa. So divisions, fractions, however you want to write it. A lot of times what I do with students is I start out with this because that's what they're more comfortable with. But eventually you're going to want to move on to using the fraction notation because we're going to get real funky with some of our division. So this is where we want to get. But again, if you want to think about this like dividing by 3 like that, totally fine for now. But yes, we want to divide by 3 because we know 3 divided by 3 is 1. And because we're balancing it, because we have to think about those scales in our head, we need to do the same thing over here, or we're not actually getting the value of x. And so yes, this becomes 1x, which we just write as x. And 12 divided by 3 is 4. And like I said, for the purpose of notes, we are using the identity property of multiplication. But again, when you see something like this, a fancy way of saying something, remember, identity, I want the same thing back. Multiplication, okay, what do I want to multiply by something to get the same thing back? So if you're, looking at your standardized tests and they're like, oh, choose the identity property of multiplication, and they give you like 4 different things, translate it. This is just, you can think about it like almost another language. Identity, you're getting the same thing back. Multiplication, I'm multiplying by something. So which one of these answers am I multiplying something and I get the same thing back? So, Crystal Coder, you ask, I have ligatures in Twitch chat? Wait, what? And Crystal Coder, you ask, is acceptable in math to do a trial and error approach to solving a problem? Absolutely. It absolutely is. A lot of times those mathematicians who find these beautiful proofs for things, they work on these things for years. And a lot of times they're like, I think this is the way to go about it. I'm going to go down this road. And then like, nope, this didn't work. So I'm going to backtrack and maybe I learned something. I'm going to try this other thing. Now, especially, I know Crystal Coder that obviously I know that you're able to code, but I would say that just like in programming, where the brute force approach is often not the most efficient one, there are smarter ways to guess and check in math. And we're going to talk about that as we progress through things, that there are, we can guess and check, absolutely. We can try to stick in values for 3 or values for x that we think might fit this and see what value we get. Absolutely. Guessing and checking is totally fine. But as you learn more about math, you'll be able to guess more efficiently or more effectively. You'll have smarter guesses. And so we'll definitely do problems where you might be guessing. And who hasn't guessed on a math test? Seriously. All right. Let me actually maybe draw a little bit of a buffer here so people don't get confused. Okay, so that we've done some of those. All right, similarly, I'm going to use one more of these. And I'm keeping the numbers simple because guess what? I don't care if you can do arithmetic or not. That's great. We can do that. If you need a calculator, that is fine, all right? I'm not here to test your ability to like who can do this, the most math in their head, or who remembers their times tables. Like, I want you to understand the concepts here. So, and Machini, you say, I got all my answers wrong because I didn't know PEMDAS and how fractions fit into that. Again, right? If you show this to like a beginner algebra student, a lot of times they're going to sit there and go, well, PEMDAS, this is a fraction. Like, if you don't teach that division and fraction are the same thing, people are going to get confused. Also, don't use PEMDAS. That I will die on that hill. All right. So similarly, right, you could think about this like x divided by 5. And yes, Natea, you've got the right answer, but let's again think about what we're trying to do here. We want to get this 5 to be a 1. So we can actually rewrite this in a way that might be a little bit clearer. This is the same thing. X divided by 5 equals 3 is the same thing as 1/5 x equals 3. I think I said, yeah, all right, I said that right. Whew, all right. It's not even getting late. I've just been talking for almost 2 hours. All right, what does hydrate do? It makes me drink water. which is always smart. So it's just a cute little redemption. I have to pause and drink some water. All right. And so yes, it's bananas. You're right. Say multiply by the inverse to get 1. But the inverse, like, I think for a lot of people, they start to think about negatives, or the inverse can be actually, that can be like a tough thing for people to remember. And I don't want you to just, memorize that 5 and 1/5 are inverses. Instead, you can just think like 1/5. All right, just like with the previous problem, I want to get 5 over 5 because I know 5 over 5 is 1. So what do I need to do to get from 1/5 to 5 over 5? Well, this is a bit of a hint. If x over 5 is the same thing as 1/5 times x, then whatever I multiply this by goes on top, if it's a whole number. Or integer, yeah. But in any case, so let's multiply this by 5. So that's going to give us 5 over 5x equals 3. That's the same thing as 1x equals 3. We're going to put a dot, dot, dot here because we need to do the same thing, right? Our balance. We've done something to the left, so we need to do something to the right. We need to multiply by that 5. Obviously, this isn't how I would encourage you to write it. If you were writing this on your own, I would consider perhaps I like to put the 5 on the outside. Makes it clearer to me what I'm doing. Make sure you do it to both sides there. Here I was illustrating this process, but this is how I would suggest doing it. Then you can just easily simplify like that. And exactly, Lucky Pierre. You say same operation on two sides. All right. So now that, and let's see, Ntruda, thank you so much for following her, NT Ruda. So, all right, before we move on, let's take a break to give the dog some treats. You all have made it through a whirlwind tour of, single variable equations. We've reviewed variables, functions. We've done a lot. So let's take a small break. And I'm gonna get the treat thing set up for the dogs. What is it called? All right. It'll take just a second to get it loaded. But do I have the next Math Monday topic set already? I do not, Strawberry Jesus. You know me better than that. I usually decide day of. I mean, I'm roughly trying to follow an Algebra 1-ish curriculum, so I'm teaching it in the order I want to teach it in, and I'm teaching it at the pace I want to teach it in. So I'm not following a curriculum, like I don't feel pressured to do things as fast or as slow as whatever. But I'm trying to make sure I hit all of the major topics in algebra, because I want people to be well equipped if they're watching this stream. Come on, load please. And Nerioli, thank you so much for following. Algebra-ish, yeah, exactly. It's algebra-ish. And can we get a stream on the world of math constants? Yes, so I want to do that. I want to do like a whole stream on pi. Because again, pi is taught terribly. Oh my God, are you ready, friends? I don't know if you're ready for this. He is too cute right now. He knows. Do you see this boy? Actually, let me see if my Furbo thing isn't working. All right, look at this adorable dog. Oh, the head tilt. Oh my God. Oh no, it didn't spit out a treat. Here you go, I'll try again. He's such a good boy. Oh my God. Oh no, is it jammed? I don't think it's spitting out treats. Oh, and he's head tilting. I feel so, oh, there we go. There we go. Just spat out a treat. All right, so that's one treat. I think we've got like 8 that all of you wonderful people donated, so we can give the boys lots of treats tonight. And Mushidi, it's not so much that they do 2 pi r instead of pi times diameter. It's that it's 2 different ways to think about it. So they're the same thing. I've seen both. He is waiting for his treat, Emma B. Oh my God, he's so cute. And Wafflebeard20, thank you so much for following. Welcome to Math Monday. We are taking a little bit of an intermission to give my dog some treats. I think you got that a little Backwards, Warzoid. 2 times the radius is the diameter. But I think your intention was to say 2R is D. And Benny White, you say, you've got an important question. What Hogwarts house do I belong to? Oh, I feel like Hogwarts is just like wrapped up in the crappiness of J.K. Rowling for me lately. It's just like, it's just this like stain that is on the series. A series that I grew up with and I really loved, but it's kind of hard when the author is a dumpster human. But I have equally been sorted by those like online quizzes. I'm about 50% of the time I get Slytherin, 50% of the time I get Ravenclaw. I know, Strawberry Jesus, that's such a good point. You say, I was thinking about, would we get the same pi in higher dimensions? I guess it should differ, but I haven't explored that yet. Well, it depends on how you define pi, right? So pi was originally defined in the context of like specific dimensions. So, oh my God, stop being so cute. He's such a good boy. And Tennessee's just over here like, it's cool if I don't get treats. I know, Emma V, I have to like tell myself that sometimes and like preserve the things I liked about it. There was a lot I didn't like, even regardless of J.K. Rowling. Hermione should have been the main character. Harry Potter was boring, but nevertheless, I still love the series. An anonymous cheer. I'll round that up to 100, and we'll give the dogs another treat just from you. Def Hacker, does Ted not even care about the treats? Sometimes he cares. Like, he's kind of getting interested, so he's coming over. I wish I could, like, aim the Furbo and, like, chuck one in his direction. Yeah, so, like, if you define pi as, like, a more conceptual representation and you leave it more open, I could see, like, you defining it differently, but, pi is the ratio. Yes, exactly, Warzoid. But we'll do a deep dive into pi and all of its goodness. I was actually thinking that might be nice for Pi Day. So I think, unfortunately, the 14th isn't a Monday, but I'll make it work. It'll be fine. Such good boys. I've lost track of all of the treats I've given them, but they deserve more. However many it is, they get more. Because they're very good boys. Oh, good. See, Tennessee's getting some treats. And Ryan 1630. All right, we'll give him one more treat just from you. And yes, Leaf Bucket, both my dogs are rescues. They're both mutts and they're both rescues, which means they come with their own quirks and their own beauty. I don't know. I love them. Okay, I'm trying. I'm sorry. Sometimes it takes a couple of tries, Hubble. Don't do that. He does that when he's like, he milks it. He just like does his downstay and just like looks so sad. And he's the master of the puppy dog eyes. This dog begs, like, it just tears out my heartstrings. Oh no, let's keep trying. We might be down to the last few treats, so the Furbo might be a little bit struggling. I'm sorry, boys, I'm trying. You're such good boys. Please, Furbo, give them a treat. They deserve it. Oh, God, and it's making the sound so they're both sitting. Like, they're so perfect. Oh, my God. It looks like it might be out. Low phone, I think it might be jammed or out. So I'll leave it to you to supply them. Oh, no. Maybe, I think it might have just spat one. But we might need a refill. I will admit something. I have a confession for all of you. Bit of a confession. I did a little bit of a trick. So I ran out of treats that fit the Furbo. So I mixed the stuff in the Furbo, half and half treats and kibble, which nothing upsets Hubble more than when I try to sneak some kibble into his treat machines, because he's like, I'm not working for this. Like, I deserve the real thing. But we were almost out of treats. So, Low Phone, hopefully you can give them a little bit of extra treats. Round out the feed. And I'm sorry, Def Hacker, I know. If we get more dog treats, we'll do another dog treat break. But all right. So let's talk about, that's what I wanted to do too. All right, so let's make it a little bit harder. Did the captions just die again? Hold on. Looks like the captions are still working. Okay. My hand is black because I wear a little bit of a glove on my hand to make sure that when I'm writing on my tablet, sometimes it picks up like my wrist or the side of my palm, and it makes it a lot harder to write. So I wear it so that the glove kind of glides really nicely on the tablet and also makes it so that it's not kind of getting confused between the stylus and my hand. Okay, so let's make it a little bit harder. So harder, single variable equations. I'm running out of room. That's quite a title. I'm trying to do better titles so that on the YouTube they sync up with the timestamps. Okay. Now, what if we have, oopsies. All right, so I know we just did the multiplication. So some of you might be rushing to go, okay, I got to get rid of this. I got to get rid of this 2. So let's use our, identity property of multiplication. Let's get this 2 to be a 1. But we kind of got to step back a little bit and we got to look at the lay of the land. All right. We don't just have a single number over here. So we have a variable. But you know what? Actually, in the spirit of, who asked me? Somebody asked me about, I'm so terrible at remembering who says things, but someone asked me about, can we guess and check? Yeah, let's guess and check. Let's do this. So what did we say we do? We multiply 1/2. Let's try it. We got to multiply 1/2 here. All right, so what I get x. And then what do I get here? So we haven't done distributive property yet, but I talked about it a little bit. I hinted at it earlier. But we can, if we can't add the x and the 5 because we don't know what the x is, we can kind of we can multiply each of the things in the parentheses by the thing on the outside. We'll go into it more. I'm more showing you that this is going to create a lot of messes for us. So now we have half of an x plus half a 5. And suddenly things are starting to just feel icky. Like, I don't think this is the most efficient way to do this. Like, this is, we're gonna have problems. Generally speaking, if things start to get too tangled, you might not be doing it the right way. So that might be an indication for us to stop and try something else. So instead of rushing ahead with our multiplication, let's think about maybe something else that we can do. And for a second here, let's pretend I'm gonna set that 5 aside. This, if you remember, when we've got the number right next to the variable, right? This is actually multiplication. So really what we have here is we have x. Remember the PEMDAS. Let's expand this. We have x plus x here equals x plus 5. So not only is this a hint, suddenly we know our answer, right? X plus x equals x plus 5. Well, gee, I wonder what x is. But also, we see very easily that we can subtract x from here. We're just doing our additive, identity property of addition, whatever. We are trying to make this 0. And so we got x plus x, we got 2 x's on this side. And we're subtracting one of them. So it gets rid of 1. And we have x equals 5. So this is a simple example, but you absolutely can find the same variable on both sides of your equation. Don't be afraid. This is a number. It's a number we don't know what it is yet, but it's a number. So don't feel free. You can multiply by it. You can subtract it. You can divide by it. It's a number. Treat it like a number, all right? It's not some like mystical thing. It's just a number. So if I give you a little bit of a harder example, let's change colors. So now we have to think about this again. We can, if it helps you to expand this into x plus x, go for it. But eventually, the more that you do it, you'll get that intuition of knowing that you can kind of subtract your x's and add them and do whatever else you need to do. So for this, we want, when we're thinking about that balance, right? We want x on one side, our bug, our spiral, we want our symbol on one side, and we need a value on the other because we want to know what x is. Hi, Mindolator. So yeah, all right. So Nateo says, let's add 5. Right. And remember, why are we adding 5? We're not doing the opposite because we just do the opposite. Remember, we want this to be 0. We want to add by 0 here or subtract by 0, doesn't matter. So we're going to try to get this -5 to be 0, but we're thinking back to our balance puzzle. We need to add 5 to both sides to make sure this equals is still true. So this turns into 0. We don't need to write zeros because they're nothing. And we know 3 plus 5 is 8. All right. Now, what are we doing next? What are we doing next? Now the fun part. All math is fun. So Nateo says divide by 2. We can try that, but I think we learned our lesson with this one, that if we divide by 2, when we've got our variable and a number over here, that we're going to get that messiness. We're going to have like 1/2 x equals, it's going to get really messy. So instead, let's see. It's okay, Mindolator. Mistakes are welcome here. We learn from mistakes. Mistakes are great. Juliosh says, let's subtract the x. I like that. We're doing the same thing here. Remember, this is a value. This is a number, just like 5 is a number. So we're going to do the same thing we did over here. We're going to make that x a 0, but we're balancing, so we got to do it from both sides. And if this is confusing, remember again that this is just the same thing as x plus x. All right, so we get 0 here. We can cross it out, which is my favorite part of doing math, is crossing stuff out. We end up with just an 8 on that side, and we know x plus x minus x, we just get x. And so now we know the value of that x. Well, one of the things that, a lot of math teachers will tell you is you should check your solution. Yes, okay, sure, but it's a great way to make sure you got the right answer. But it's actually, I like it because it reinforces this idea that, yes, the variable's just a number. So if we do that, let's rewrite our problem. And we know what x is now, or we have a theory. Maybe we're guessing and pardon me. So we think it's 8. All right, 8 plus 3, 11. And remember, we're not following PEMDAS, but we remember that this is just a shorthand for addition. So we need to expand this out. And instead of sitting here and writing 8 2s, which, my arm, we're going to solve our multiplication first. So 8 times 2 is 16. 16 minus 5 is 11. Are these balanced? Is this equal? Yes. Then we have the right answer. We are masters of the universe. We did it correctly. And Mushini says, checking is kind of magical. It's so true, isn't it? I love that feeling of plugging back in and you're like, yes, look at that. I proved it. I'm right. I'm awesome. So, yay, Def Hacker. I'm so glad. You know what? Math Monday is the way to start your week off right. Everyone's like, meditate, tea, go to bed early. I'm like, nah, Math Monday. And the rest of those things if that's your jam, but also Math Monday. All right. So, let me see here. Just looking at my notes. Loafbone, thank you so much for the gift sub. Thank you so much. And yay! Def Hacker, now you have all the cute dog emotes. And also the Jess Pog one. And gaze into the iris. That's an excellent point. So you say you can use that to balance chemical equations too. Yes. And so, I mean, this is what I'm talking about, is math is like the structure that underpins everything. Reality, honestly. And so it's the language that we use to describe reality in a lot of ways. And so now once you're starting to learn these concepts, you will see them everywhere. All right. Now let's talk about something though, which is which one did I want to do next? I will do those. Should I do them now? Yes, I'll do them now. All right. Well, so we talked about this balance, right? Sometimes we might not know a relationship where x plus 5 equals 10. We might not have that much information. And so we're going to use something called inequalities, right? They're not equal, they're unequal. Where's my space pen? To describe relationships where we don't know enough. Unequal. This is what happens when I talk. Here we go. Gotta spell it right. Hi, Mirabic. All right. So these are where we don't know enough to be able to say exactly what x is. We can, however, kind of give a sort of guess, or we can kind of say, we can constrain it. We can say, I know that x is, at least I know it's less than 5. So in this case, inequalities are, instead of the equal sign, we're going to have less than, greater than, less than or equal to, which just looks like the less than sign kind of smushed together with the equal sign, or greater than or equal to. So again, right? Nothing mystical about this, but nobody wants to sit here and write these words out. So we're going to have symbols to take their place because that's a little bit more efficient. Okay. Oh, I see, Yogi. Thank you. You're really the best teacher of the world. Thank you. Thank you. Please get sleep. No worries. Thank you so much for stopping by. Hopefully I will see you next time. Okay. So less than, greater than, less than or equal to, greater than or equal to. So if I say something like x is less than 5, well, there could be a lot of things that x could be. X could be anything that's less than 5. So yeah, I know it's not as great as having an equals. Like, it's not as definitive, but it still kind of gives us a place to look. If you are one of my number line lovers, then here's how you show it. So before, I would kind of put, a big dot where our number was, but here we're not quite sure where it is. And we know that it can't be 5, so I'm going to leave this open, because 5, I'm not going to color it in because I know it's not 5, but it could be anything less than 5. So instead, we kind of draw this line because it really is, it could be any of these values. If I have, x is greater than or equal to -2, perhaps, we're getting a little funky. Then, and let's see, Crypt Exust. Thank you so much for following. Welcome to Math Monday. All right, so in this case, well, we know it could be -2, right? It says x is greater than, so I know it's going to be larger than -2, but also we've got the or equal to. So in that case, I'm going to fill this in just to kind of tell myself, all right, it might be -2, but similarly, we just draw a line in the direction of what represents kind of our relationship here. Wait, what? Oh, Lofo misinterpreting the ideal gas law. All right. Okay. So pretty much the rules here are gonna stay the same. we're going to put negative numbers aside for now. Some funky stuff happens when you're multiplying or dividing by negative numbers with inequalities. We're not going to cover that today yet, but just keep in the back of your mind for now that stuff gets a little bit weird when we use negative numbers. So let's just talk about positive inequalities for a second. No System 58662. Thank you so much for following. Welcome to Math Monday. All right. So guess what? It's pretty much the same. You've done all the hard work already. If I say x plus 2 is greater than 7, oh no, this isn't an equal sign. Well, guess what? We're going to treat it like one for the sake of solving this problem. So, same stuff. You all are pros at this now. We want the 2 to be a 0. We're going to use our identity property here. We're going to do the same thing. And we get x is greater than 5. Easy peasy. Same thing holds for multiplication, division, addition, subtraction, everything you just did. Remember, put a little like asterisk there for yourself going, but I know something funky happens with negative numbers, and we'll talk about that in the future. So I did want to show you this because some really cool stuff can happen when we get more than one variable. So we talked about this a little bit last time, right? Where, and this is, by the way, where we're getting into our more than one variable linear equations. So this is where, we have a relationship between two variables. So if you remember, the Hubble is 2 times the way to Tennessee. That's what we're talking about here. Or let's make it a little bit simpler. And let's say Hubble's food is equal to whatever Tennessee's food is. Probably plus 2. Let's say plus 2. Okay. Now, if I'm, we're mathematicians now. We don't want to have to write all these words out. So I'm going to say Hubble, H for Hubble, is equal to Tennessee's food plus 2. Now, a little bit of a refresh from last time. Remember, and as I talked about earlier in this stream, we can kind of take our 2 number lines representing Hubble and Tennessee. We can stick them together. Let me use some different colors. What am I even doing here? What am I even doing? I have all these fun pens, and I'm not making use of them. Auroral Games! Oh my goodness! Hi, Raiders! Welcome, everyone! Hi, how are all of you doing? Yes, let's get a shout out, please, for Auroral Games. How was your stream? Oh, cool. Is that, it looks like Unreal? Maybe? Oh, and also that's really creepy. Oh my goodness. Is that is that like the Pit Boy from Fallout? That was a terrifying clip. Holy crap. Oh my gosh. That would scare the crap out of me if somebody did that. And yeah, hi Acania Dev Sky. So I'm not just a math channel. So Mondays are for math though. Math Mondays. I'm doing a stream series called Math Mondays. That starts with algebra and is going to take you, well, as far as all of you will stick around and watch with me. So we can go all the way through multivariable calculus, differential equations, and beyond. But for now, we're going to start with algebra. And Rafa Prado CGI, thank you so much for following. But if you will check out the schedule, which I think I still need to update because it says Math Mondays are starting soon, and they have indeed started. You'll see that Science Sunday, we do astronomy, machine learning, data science. I've got a series going on. I'm doing some Science Sundays, which is the fundamentals of data science. So yesterday we talked all about machine learning and specifically the machine learning problem of classification. And Thursdays are game dev, so I'm a total beginner, so don't expect much. But I'm learning Unity and C# and learning how to do cool stuff in Unity. Keystorm, thank you so much for following. So lots of fun things. Feel free, if any of those stream series sounded interesting to you, you can check out my YouTube channel where I have VODs for all of the tutorials I do. So I don't put game dev on YouTube because I'm a disaster. I'm not sure anyone would learn much from it. I learn a lot, but they're not really like super structured. Whereas Sunday and Monday streams are often kind of more educationally focused. I'm usually like teaching a topic, so those will be on YouTube. The code is all on GitHub, and for Math Mondays, the images for Math Monday from the Blackboard can all be found in this Google Drive. But Vinavan, thank you so much for following, and Gobfather, thank you so much for gifting a sub. Now, Auroral Games, you have access to wonderful, cute emotes of my dogs for the most part, and I think a Pog one for me. Inconst XPR, thank you so much for following. Yes, my own little Pog champ. And you ask any statistics, so absolutely. I do cover, so typically for the data science or machine learning streams, the first segment of the stream is on theory. So that's where I cover the concepts, make terrible drawings, do the math. And then the second half of the stream is often coding in Python. So showing you how to build these models or implement them using the most frequently used Python libraries for data science. Thank you so much for following Acania Dev Sky. All right, so today, like I said, we're talking about algebra. We've just started algebra. We talked last week about variables and functions. Today we're talking about linear equations. We've talked about, I've gotten on my soapbox twice now about PEMDAS and why it's trash. We've also talked a little bit about negative numbers, started to work some, equations that have more than one step. So we're ramping up the difficulty. And you say, sorry, I don't have electricity. Oh my gosh. Hopefully, you could be anywhere in the world, but I hope that you're not in the south of the United States. There's some really bad ice storms there. And I hope that you're safe regardless of where you are. Oh, yeah, there's some bad snow and ice in Texas right now. But, you say algebra is your favorite math area. You're super rusty, though. No worries. That's why we're here. So this is often, I picked algebra to start with because it's often where people start to struggle. So a lot of times when I've been tutoring math, I've found that this is the area where the most people start to get lost, is Algebra 1 or Algebra 2. So you know what? It's the perfect time to refresh. And if you're like way beyond this and you're like, nah, I know all the math, I think it's still fun to hear basic concepts explained in different ways and just sit around with people that also like snow, like math. I saw your Let It Snow, Lucky Pierre. That like math and have fun. Emma B, I think we might be the same person. You say, I began to struggle in geometry, but I thrived in proofs. I was the same way. So I actually failed geometry the first time I took it. The teacher that I worked with was wonderful, though, and found a way for me to, not fail the whole year. I was wicked good at proofs, but geometry just didn't mesh with my brain. Algebra 1, I was good. Algebra 2, trig, all of that. Perfect. I got A+ in calculus, and yet geometry just... So you know what? We'll see how the geometry streams go when we get there. You all will have to be very patient with me. And Davitada, thank you so much for subscribing. Now you also have cute emotes. And no ads, I think. But hopefully I'll have more emotes and cool stuff for you folks very soon. I'm working on it, so stay tuned. Well, so Warzo, you say, don't proofs require really good knowledge of geometry? It was proofs were the place where geometry acted like algebra to me. That's the only really way I can describe it. Trig proofs I liked way more. They were like puzzles I was trying to solve. But when there were circles and lines and shapes and find the angle of the... I don't know why, I just didn't. My brain, nope. Exilius333, thank you for following. And let's see. Oh, no, you are in Texas. Okay, well, I hope you're safe. I hope you have supplies and whatnot. I've heard it's really nasty and quite a brutal storm. So I hope you're safe and your friends and family are all right. And let's see here. Emma B, you say, or no, let's see. Aurora Games, you say, that's how you were with calc? All of the math you're okay, then calc just ruined it. No, well, I hope that you'll be back for the calc streams then, because calc is where I fell in love with math. So that is where math like became beautiful to me. Before that, I was like interested and I started to get good at it, but I was like, okay, like I like a lot of other stuff too. And then calculus happened and I was just like, wow, this is incredible. So hopefully I can impart some of that awesomeness to you when we get there. And maybe you say you almost wanted to retake it because I think I got like a C, and the only time I was number one in geometry was doing proofs. I think we might be the same person. But yes, exactly. You say proofs were easy because it was like shaping a map. I like the way I think. That's a cool way to think about it. No, calc is where people quit math, but friends, calc is where it gets really awesome. I can't wait to get to calc. Like, do you know how much patience it's taking me to go teach them right, start with algebra, when everything in me is like calc, because calc is just like, there's a lot of simplification that you have to do before you learn calculus. So when we work with algebra, it's great, but we're limited. We can't describe all relationships just with algebra. We can't model everything. And especially differential equations. That's where it was like literally so grounded to me, and like I can look at stuff that happens in the real world. I can turn it into math. Like I have the power. So, I can't wait. It's going to be so good. Rich Easy, thank you for following. And no, it's so in Const, you say you betrayed it all and went to computer science. My day job, I'm a machine learning developer. It's not a betrayal. You are still using that analytical thinking, that logical thinking. So you're not betraying anything. Next, Silas, you say, I almost quit calc because the teacher didn't explain why we took limits. In AP book, I read one paragraph that made limits make sense, then calc was simple and fascinating. I can't tell you, and also, this is why I made this stream, is I can't tell you how many times, like, bad teaching turns people off of math. And it just breaks my heart because math is so cool and it's fun and it doesn't need to be scary and it doesn't need to be like brutally difficult. Now, when we get to things that are really hard, I will tell you, like, this is hard. It's supposed to be hard. So I think there's a distinction between things that are artificially difficult because they're taught terribly and things where, no, seriously, this is a complicated thing. Like, it's okay. Like, you should struggle. And I feel like we don't distinguish between those. And there's a lot of, like, people think that to get people interested in math, we have to tell them it's easy. Math challenges you. It does. There's going to be times where it's hard, but it's supposed to be. Anything that's really complicated or advanced, it's going to get hard. And that's okay. Like, sometimes we're going to struggle. And I feel like, not to mention, you know, our education system makes the struggle sort of like punitive. Like, you get penalized if you struggle. But like sometimes struggling is the point. In any case, hopefully all of you will stick with me and we'll struggle together, and I will hope to make the struggle at least somewhat enjoyable. And even for you, thank you for following. An accent US, this seems to be middle school math. What's the point of teaching it here? Well, there are several people already teaching more advanced topics on Twitch. If you want that, you can go watch their stream. But if you were to take, like, go and look up studies about when people start to struggle with math. And from a pedagogical point of view, people start to struggle with math. They start to hate it. They start to acquire gaps or misconceptions. That starts to happen. The largest point of that is the transition between arithmetic and algebra. And the next part is actually when you start to move into calculus as well. So I want to make sure everyone has a really good foundation. If I started with calculus, I would probably be having to stop and explain concepts from algebra that people either forgot or they misunderstood or they were taught poorly. So rather than that, where if I start right with calc, a lot of people are going to tune there and be like, this is beyond me. I don't remember this. Like, see, I'm bad at math. That's the opposite of what I want. I want math to become more accessible, and I want people who hated math to learn maybe to like it and appreciate it, hopefully love it. But I also want it to be like, we have to start at an accessible point in math for the most amount of people to learn from it. So let's see. Catching up on chat, I missed a lot, I'm sorry. Oh yeah, no worries, Lurk, Auroral Games. Trust me, I know the post stream veg, so just relax. Like, please don't feel like you have to engage Lurk or just sleep or whatever you need, because I know, like, the first thing after stream is I get on the most giant PJs and, like, all I want to do is eat snacks and play video games. So relax. And let's see here. Godfather, I used to challenge math like you until I took a geometry to the knee. Yes, gaming memes. And let's see here. And I mean, so Machine, you say, I think you guys don't give yourselves enough credit. You find a lot of things easy to learn and still benefit. So I think the difference to me is that a good teacher can explain from the simplest concepts to the most complex concepts, things in a way that will help a student who finds it difficult regardless. So if you find something that other people find simple, if you find that difficult, that's okay. Like, I'm here to help everybody at all levels. So I think sometimes it's more about the teacher in those cases. Oh, Modkit, yay! You say I make math sound really fun? Yes, all right. Mission accomplished. Now I feel like I need my, like, math superhero cape or something. And you say I'm curious, you're curious about my coding work. Well, I have just a little bit left to get through for the Math Monday stuff, but then I like to do a Q&A at the end. So ask me all the questions about programming. Let's see if we can get back on topic for a little bit, and I will answer all the coding questions during the Q&A. All right. Let's see here. Okie doke. All right, I'm just gonna refill. I've been losing my voice a lot more on streams, which is really funny because, I mean, I've done streams that are 6-7 hours long and I've been fine. And then there's like 2-hour streams where I start to lose my voice. Okay. All right. Haha, Godfather, don't be a troll. All right. Oh, shoot. Ah, here it is. Okay. Put down my stylus. So, coming back, all I was reminding you is that we're just taking two number lines. And because we want to see the relationship between those two things, we're going to, just kind of rotate one of those number lines. And suddenly we have what you might hear like called your Cartesian coordinates, or like your Cartesian graph. Don't worry about the fancy names. We're just looking at the relationship between Hubble's food and Tennessee's food, my two dogs. So you have Hubble's food, this is Hubble's food, number line, this is Tennessee's food. All right, and what is this relationship that we have? We have that Hubble's food is whatever Tennessee's food is plus 2. Cool. So how do we start to model this relationship? Well, let's plug in some numbers and see what we get. So when Tennessee doesn't have any food, so when Tennessee's food is 0, right? This becomes a 0, so we can ignore it. Hubble's food is 2. So that means we've got a point here. And see, we're filling it in because we know that this is a value. What else? Let's see. When Tennessee has 1 cup of food, Hubble would have, what, 1 plus 2? 3. Oof, that was a little. So then we have another point here. Let's let's say Tennessee has 3. And Cypher PH4, thank you so much for following. So in Tennessee has 3, 3 plus 2. Hubble has 5. All right. And these are like terribly drawn here, and things are not equally spaced. So you have to bear with me. This is roughly a straight line. Okay. Now I got a question last time, and I've been thinking more about it, of, well, how do we know that this relationship continues? Well, we know that this relationship continues. We know that we can make this into a line because essentially we could fill in every possible value here. And like, we could do that. We could fill in every single value. And that's what this line represents. This is, we talked about this last week, but we talked about this being the relationship, right? This is our relationship between Hubble's food and Tennessee's food. Whatever our variables are, this is modeling their relationship. But now we know something else, right? Think back to those equations we've just been messing with, right? If I have, this equation, Hubble equals Tennessee plus 2, and I plug in, 0 plus 2, Hubble is 2, what have I done to this equation? We've solved it. That's just what we were doing for like the last half hours. We were solving these. So this isn't just telling us the relationship. It also is graphing for us. It's showing us every possible solution. It's the relationship and it's every possible solution. So every possible combination of Hubble's food and Tennessee's food that fits this rule, that fits this pattern that we have described with math. It does default to weird spots, sorry about the captions, but you should be able to customize them to whatever you need. And this is really, really cool because now we can connect solving our equations like we were doing with a picture. So we can solve it with math. We can also solve it and see where every possible, this one is like so badly placed. Should be more like here. Well, that's what you get with my terrible drawing skills. All right. Close enough. You see nothing. I'm trying to make it look nice. And I just made it look a whole lot worse. Sident24, thank you so much for following. All right. I know, Def Hacker, you say, I honestly wish every Twitch stream had that add-on. I personally think Twitch needs to embed them into the videos itself, just like YouTube does, but maybe higher quality, and make it so that, it's something that's in every single Twitch stream. Don't put the burden on Twitch streamers to make things accessible. You should have accessibility built into your platform. People can turn them off if they want. They can customize them, but they're there. It's ridiculous that they're not. And Codephiliac, thank you so much. Welcome to stream. Okay, so it's within the standard deviation, right? Gaze into the iris, close enough. All right. So, and this is, remember, line. So we are talking about a linear equation. Remember, again, we got that equal sign. It's linear, it's a line. But let me ask you this. I'm gonna throw a little bit of a curveball your way. What if, Hubble eats a lot of food, and it really depends on the day how much food he eats. So what if I know that sometimes, Hubble's food is T plus 2. It's Tennessee's food plus 2, but it could also be a lot more food. How do we represent that graphically? Well, here's how I like to think about it, is that I first pretend that it's an equals, and you get the relationship, right? You get what it would look like if H equals T plus 2. But I know H could be greater than that. And remember, this is H, so any value H greater than this is fair game. And this is where we get to shade. So to represent an inequality in a graph, you just get to shade it. Be like, hey, it's anywhere in here, anything here. Could any of these are possible solutions? So if you think about it, the list that we could make of all of our possible solutions has suddenly gotten a lot bigger. But that's also because we don't have that firm relationship of equals that we do when we're just doing a linear equation. So there you go. Now you know how to graph linear equations. You know what a graph of a linear equation looks like, what it means. You can solve some single variable equations. We did a little bit of a review of negative numbers. We started solving inequalities. And pneumaticist, thank you so much for following. And I'm going to leave you with a little bit of a teaser for next time. And then we'll do Q&A. So, preview, maybe I'll call it. And Phils, thank you so much for following. And Carlos, let's see, Henrique Vital, thank you so much for following as well. So here's a little bit of a preview for next time. I know so many people are already going to know the answer to this, but I want as much as possible. Don't jump in with that knowledge you've memorized, right? This is a zero memorization channel. No memorizing anything. I refuse. I ban it. It is banned. None of that. I want you to understand things from kind of those first principles. So let's say, so when I give you this problem, try your best not to think, oh, here's like what I've memorized previously. Try your best to think about it in the terms that we've been talking about so far. And because I'm not going to do this in my head, I'm going to grab an example from the internet so that I know this actually can be solved. Because I don't want to do it in my head. It will be terrible if I do it in my head. All right, that'll work. So what if all right, so we're going to go back to y and x because we're not talking about Hubble in Tennessee, but we could if we wanted. Let's say that here's one of my equations, all right? And remember, if I were to graph this, what would it be? It would be all of the possible solutions for this. But sometimes one rule isn't enough. One rule isn't enough to illustrate more complicated things in the world. Sometimes you might have multiple rules. So if this is one of our functions, one of our equations, one of our rules, and this is another. Now, we're not going to solve them, okay? But if I can graph this, right? So whatever the graph is, and I can graph this, like, meep, whatever the graphs are. This is an like approximation. Do not use at home. Think about it. This represents all the possible solutions for this. This line represents all the possible solutions for this. If I want to know something that solves them both, what might I do? Don't try to not jump right in with your like, oh, I've memorized this, but think about it conceptually, right? When we draw that line, we're just literally, it's an infinite amount of little points, and all of those little points are possible solutions. All right, let's try that. Yeah, if we were to, and again, approximation, but if we were to try to put these on top of each other, I'm trying to at least make it like somewhat. Well, there would be a point that they share, a point they have in common, right? A point, what are our points on our lines? Our points are solutions. They have a solution in common. The solution they have in common is where they intersect. And so this is something called systems of linear equations. We have more than one, so it's a system. And we'll talk more about solving them, ways to solve them, what even is happening, why you care, why is it getting more complicated? Oh God, math is awesome, but yes, we're gonna be doing more than one equation at the same time because, come on. When you can do one, you can do two, I promise. So that is a little bit of a preview for next time. That's something we'll be talking about for our next day of Math Monday, which consequently will be next Monday. But yeah, so let's take a look at what we've talked about today. And also how balanced my notes were. Not bad. They're not all in one line. Okay, I didn't do so bad. So we reviewed variables. We reviewed why PEMDAS is poop. We talked about what a function is. We introduced linear equations. We went through single variable, harder single variable, inequalities, two variables. We talked about graphing them. And I gave you a little bit of a sneak peek for systems of linear equations. So let's pat ourselves on the back, because that was a chunk of math. Like, some of you have been here for almost 3 hours of math. How many of you have been in a math class that's like 50 minutes, an hour, and you're like, I'm dying. When is this over? And you just sat through 3 hours of math. Maybe you like it. Maybe math is awesome. Maybe I'm secretly corrupting you to find math really cool. You say thank you for existing. You're welcome. I don't have much choice, Codephiliac. Yes, Dota 2. Gotta represent. Also, if you like Dota 2, you will love my menagerie here of Dota 2 like figures that I try like when I'm having a real bad day at work. I've got the Dota figures that I try to emulate. So I got my Ice King, Lich, because sometimes you just need to freeze somebody. I've got Tide Hunter for when I'm just like raging a little bit. Just gotta Hulk out. And I got my girl, Phantom Assassin, because sometimes you feel like you really want to, crit on somebody. So these are what I channel sometimes when I'm having a bad day at work. Oh no, the little disc fell off. Hold on. Oh, come on, stick your little foot there. Thank you very much. All right. And thank you, Lucky Pierre. I'm glad that you're finding the content useful. I'm happy to help. I like teaching math. It's fun. And I just feel like there's so much damage to undo, but like sometimes it feels like weeding a garden, which is also something I really like doing, which is there's like all of these bad ideas that have been planted by someone else, either by yourself. You're like, you don't believe in yourself, which is fine. Like I got that too. Or ideas that are planted by bad teachers. And like, I'm sitting here, I'm just going to weed it out. I'm going to pull up all these weeds and we're going to plant some math awesomeness. So that's kind of a bad metaphor, but whatever. The Funko Pop Assassin. I know, I love it. I'm not usually a big fan of Funko Pops, but this one I was like, yes. I like totally play, well, I often am playing with people who are much better than me, so I usually default to playing support. But when I get to practice kind of carry on my own, I like playing PA. So Bogart and Star Fox. I think I missed Star Fox. I'm sorry. I think I might have missed your follow. And Bogart, welcome to stream. Okay, so I know there were questions about programming. I think I saw a question about code going by. I'm trying to scroll back up. I wanted to get through the rest of math first. Pneumaticis, you ask if there's any stats or coding-based streams. So I would encourage you to come to Science Sunday. That is when I do machine learning, data science. Sometimes we'll have astronomy streams, so like those are a little bit more casual and laid back. But a lot of times, if you're interested, statistics, machine learning, data science, pardon me, Sunday is going to be the day for you. I also do programming on Thursdays. I'm learning game development, so I'm learning C# and Unity. So that's where you get to see kind of me learning. So if you're tired of me teaching you things and you want to see me making a fool of myself, swing by on Thursdays. But let's see. And Jay Shady, did I miss something? Or no, you're just saying hi. Okay. And Master Darkweave, you say you've had to deal with junk closed caption generators your entire life. They need to be better. Agreed. So I think that the assumption there is that you're going to use a quality one. And the frustrating thing is that, and this is the really frustrating thing, is there's plenty of third-party plugins that work extremely well. So there's no excuse for having bad captions. There's just not. And Jay Shady, yes, I'm sorry, that was your question. I do play Dota terribly, miserably. I've also done machine learning for Dota stuff, so cool things. And Code Philiac, you ask, so what do you think of OpenAI's Dota 2 bots? Super cool. Are you kidding me? I'm like, oh, reinforcement learning is my favorite part of machine learning. So deep reinforcement learning, it's such a cool, complex problem. So I love it. And Nematocyst, you ask if I mostly code in Python. So for streams, it's Python or C# for the most part. For work, it could be a whole lot of different things. Lately, I think I've had to do C++, MATLAB. I don't know much C++. I can muddle through because I did some C. MATLAB I did in high school, so that was a bit of a throwback. And Python, because Python really is like the standard language for machine learning. So, and Cyrate, you're using Unity too. Awesome. I'm very new to it, but it's really cool. And I'm loving learning C#. It is such a neat language. It is a blast. It's my new, I feel like it's kind of like, I don't know, like, how to explain it. No, I don't have a timesheet today. It's my timesheet alarm, but I had a holiday today. It's like my fancy new friend. I'm just showing it off. I love C#. I've heard good things about Unreal too. I started learning Unity because my friend is a AAA game dev and he's the one teaching me. So, as long as it's not JavaScript. No hating on languages here. No hating on languages. I myself have struggled a bit with JavaScript, but I would love to be better. So, and Cyrade. The JavaScript got picked up by Automod. Seriously? Sorry. That's a little bit funny. Cyrade, you say, fun fact, C# language has got some peeps from the Pascal crew. Oh, cool. Yes, I'm glad to find another person who loves C#. I love it, love it, love it. I'm still learning the basics, honestly, but every time I learn something new about C#, I'm just blown away, especially when it's like smushed together with Unity. It's like match made in heaven. It's awesome. Hi, Luke. How are you? I'm doing well. We're just wrapping up Math Monday here. And yeah, okay, so Emma B, are you in Learn with Leon's bootcamp? Because he's doing full stack JavaScript as well. So that's a great resource for you if you're not already part of his crew. But all right. Oh, you are? Good. Okay. I was about to say, you better be. What is your homework for tonight? No, there's no homework in my streams. And User Tew and Lucky Wanderboy, thank you so much for following. If you want to practice problems, I would say go for it. If you get stuck, hit me up in Discord. But no, there's no homework. This is casual. It's just about, you're here not to have to work. You're here because you want to learn. So, and Tom Hardy's, thank you so much for following. And yes, Jay Shady, I usually start at 7 p.m. Eastern Standard Time. Sometimes if I'm having difficulties, I push it to 7:30. But usually I try to be on time and I try to start by 7. All right, so let me look up a couple of things here for us. All right. I have somebody that I would really, really, really like to raid tonight. Okay? She's wonderful. She went all the way through the 12 Days of Machine Learning Miss with me. Like, super, super cool human. Small stream. So I would... Wait, Strawberry Jesus, did somebody do a redemption for a story time? Loafwood, can you check redemptions for me? Did I miss one? And Cyrade, thank you so much for following. Not yet. Hold on your redemptions. We will do, You promised class 10 song. Oh my good lord. Okay. No more story times. If you don't waste your points, Loafbone will redeem them. I gotta get to bed. I'm sorry. We'll do a Tennessee song. Let me do a poll. Hold on. For those of you who are new to class, new to stream, my dog sings for you at the end of my streams. I wasn't gonna do one tonight because I'm really, really tired, but Loafbone is demanding it, so we'll do it. All right, how is the topic chosen for Tuesday? So hold on the Tuesdays for now. I'm trying to find a new time. Loafbone, are you just gonna pick? Okay, fine. Loafbone is picked for us. Thank you, Loafbone. And Goddard J2, thank you so much for following. Go NASA. I am on the East Coast. Topics are chosen for Tuesday via redemptions. So I would say hold off because Tuesdays aren't working for me anymore, so I have to move them. So I'm considering Friday. And once I have that time locked down, like Friday nights or something, then I'll be able to do the viewer's choice. And so if you've redeemed a science topic or a game, then I do Friday night all about that game. Like I'll play the game. Or I do Bueller science topics. Now that said, this Friday, tentatively, I have something extra cool planned for all of you, which is that my friend, PhD in, marine neurobiology, previously streamed with me the science of Subnautica. And so I think we're going to come back. We might do the science of Subnautica Sub-Zero. So the sequel to Subnautica. She comes in and we play in creative mode, but we zoom all around and we look at all the different species, and she answers all of these really fascinating questions all about marine stuff. And I get to be the most ignorant person in chat because I know nothing about fish or water animals. In any case, her research focuses on really cool brain stuff with mantis shrimp. And that's about all I know. But she's brilliant. She's amazing. Stream last time was a blast. So if science of Subnautica sounds like your kind of thing, come have a marine biology hangout with us on Friday. And I'm not going to read out chat because I'm trying to keep this educational. Anyway, don't go anywhere. I see some of you leaving. Tennessee will be heartbroken. This is his favorite part of the day. Sometimes he thinks that I'm streaming when I'm not, and he just zooms down the hallway ready to sing for you. So please don't go anywhere. He loves singing for all of you. He's very good at it. And I'm going to go grab him, put my green screen down, and when I come back, my dog will sing Star Trek Voyager for you. And somebody loop Jay Shady into the meme there. Gwyn Blenson, thank you so much for following. I will be right back. All right, I have a very, very good boy here for you. Give me 1 second. I have to take some of the filters and stuff off of my webcam. So give me just a second. Okay, he is like jumping. He is so excited. This is ridiculous. Get excited. He is such a good boy. All right, and I'll make this super large. Okay. All right. That'll have to do. I'll get him on the rug. All right. Here you go. Here's your mic. You're a very good boy. And he gets cheese. Okay. Oh, I know. Are you prepping? Come on. Over here. Okay. Give me a sec to get the song up. I'm also going to turn down the mic and a bit of a volume warning because he's a diva. He gets very loud. Love phone requested. Voyager. All right, Tennessee. Over here. Sit. 10. Sit. People see you? All right. There you go. Perfect. On the rug, too. Stay. Oh, yeah, I know. Add.
I feel like everyone has their
Let's turn down the mic.
experiences that
Here we go. Tennessee sings for
no
you.
one can take that away from you.
Tennessee.
A new world forward, better than how we
Tess,
found it.
sit. Good boy. That was such a good song. Everybody loved it. You were such a good boy. Everybody thought your song was amazing, Tennessee. You were the best boy. You're such a good singer. It's a good song. Good song, little boy. Good song. You did a great job. All right. That's what you get to look forward to when you stick with me through streams. I know, standing ovation for the world's best singing boy. All right, now, please, please, please don't go anywhere. I have been wanting to raid this person for a while. She's awesome, learning Python, learning data science. She has been here through so many of my streams, and I would really love to pay it forward, show her some support. So we're gonna do a raid. Try to stick around if you can. Throw some love. And I will see you all Thursday for Game Dev. And in the meantime, join Discord, look at stuff on GitHub, YouTube, etc. I'll see you all next time. Have a good night. Oh, wait, no, it takes a minute to... I'm the worst. I always forget there's a countdown. Bye, everyone. Have a good night, friends.